Level 1. You're moving at 1.3 million miles per hour. Everything you're about to hear will challenge what you think you know about reality. These aren't theories. They're verified facts about the universe that most people never learn, because they fundamentally break our everyday experience of existence. Starting with your body right now. You feel completely still, sitting or lying in place, experiencing the sensation of motionlessness that defines your moment-to-moment perception of the world. But the reality is that you're hurtling through space at roughly 1.3 million miles per hour, a speed so incomprehensible that if you could suddenly perceive it, your mind would struggle to process the velocity. This motion comes from multiple simultaneous movements layered on top of each other. Earth rotating at about 1,000 miles per hour at the equator. Earth orbiting the Sun at 67,000 miles per hour. The Solar System orbiting the galactic center at 514,000 miles per hour, and the Milky Way itself moving through space at approximately 1.3 million miles per hour relative to the cosmic microwave background. Your nervous system evolved to ignore all of this because acknowledging it provides no survival advantage, creating the convincing illusion of stillness that you mistake for objective reality. Every sensation of being stationary is your brain filtering out motion too vast to be useful. Level 2. Starlight time machines. When you look up at the night sky and see a star twinkling, you're actually watching light that left its source years, decades, or even centuries ago, traveling through the vacuum of space at 186,000 miles per second, crossing distances so vast that by the time the photons hit your retina, the star itself might have already died, exploded, collapsed into a neutron star or black hole, meaning you're essentially looking at ghosts, not metaphorical ghosts, but literal ghosts, the fossilized light of objects that no longer exist in the form you're perceiving them. This creates a strange temporal dislocation in your everyday experience that most people never consciously process. Every time you glance upward on a clear night, you're seeing the universe not as it is, but as it was. Your vision reaching backward through time in direct proportion to distance, making your eyes a kind of biological time machine that operates on the fundamental principle that information cannot travel faster than light. The present moment of distant stars is forever inaccessible to you. Level 3. The sun's 8-minute delay. The sunlight touching your skin right now is 8 minutes and 20 seconds old, having traveled 93 million miles through the void at light speed before reaching Earth's atmosphere, which means that if the sun suddenly vanished, blinked out of existence completely, you would continue living in sunlight, experiencing warmth and illumination, completely unaware of the catastrophe for over 8 minutes, during which time you'd go about your day under the light of a star that no longer existed. This temporal lag applies to everything. The gravitational pull keeping Earth in orbit would continue for those same 8 minutes before the planet suddenly slingshot into deep space following a straight line, obeying Newton's first law of motion. The light itself began its journey deep in the sun's core roughly 100,000 years ago, bouncing between atoms in the radiative zone before finally escaping the photosphere and making the final 8-minute sprint to your location. You have never seen the sun as it currently is, only as it was slightly in the past. Level 4. Moon illusion. Mystery. When you see the moon hanging enormous on the horizon compared to its appearance high overhead, you're experiencing an optical illusion so convincing that it persists even when you know intellectually that the moon's angular size doesn't actually change, remaining approximately 0.5 degrees across, regardless of its position in the sky. Scientists call this the moon illusion, and despite centuries of research, there's still no universally accepted explanation for why your brain interprets the same sized object as dramatically larger when it's near the horizon versus when it's directly overhead. The leading theory suggests it involves Ponzo illusion mechanics. Your visual system uses terrestrial reference points like buildings and trees to unconsciously scale the moon larger, treating it like a distant object that must be huge to appear that size. But this doesn't fully explain why the effect remains powerful even over empty ocean horizons. You can prove the illusion instantly by holding your thumb at arm's length and comparing it to the moon in both positions. The moon's actual size never changes, but your perception shifts dramatically based on context your conscious mind never notices. Level 5. Stars don't twinkle in space. The twinkling of stars that you observe from Earth, that characteristic shimmering, the romantic flickering that defines the night sky in poetry and song, doesn't actually exist in space itself, but is purely an artifact of looking at point sources of light through Earth's turbulent atmosphere, where pockets of air at different temperatures and densities act like moving lenses, constantly bending and refracting the starlight in slightly different directions dozens of times per second. Astronauts in orbit report that stars appear as steady, unmoving points of light, perfectly stable and motionless, because there's no atmospheric interference to create the scintillation effect you're familiar with from ground-based observation. This is why astronomical observatories fight so hard for high-altitude locations, and why space telescopes produce such dramatically clearer images. They're eliminating the atmospheric turbulence that creates twinkling. The romantic flickering you associate with stars is actually the signal degradation caused by looking through miles of churning air. Planets twinkle less than stars because their angular size is larger, meaning atmospheric distortions average out across their visible disk rather than affecting a single point. Level 6. The dark side. Myth. The phrase dark side of the moon creates a fundamental misconception that persists in popular culture. The idea that one hemisphere of the moon never receives sunlight, remaining in permanent darkness, when in reality both sides of the moon experience roughly equal amounts of sunlight over the course of a lunar day, which lasts about 29.5 Earth days. What you're actually dealing with is tidal locking, a gravitational phenomenon where the moon's rotation period exactly matches its orbital period around Earth, meaning the same hemisphere always faces you, while the opposite hemisphere always faces away. But this far side, not dark side, receives just as much solar illumination as the near side you observe from Earth. The confusion arises because, from your terrestrial perspective, you never see the far side naturally, leading to the intuitive but incorrect assumption that hidden equals dark. The first humans to see the far side with their own eyes were the Apollo 8 astronauts in 1968, who described a landscape just as illuminated as the familiar near side, just never visible from Earth's surface. Every location on the moon experiences approximately 2 weeks of continuous sunlight, followed by 2 weeks of continuous darkness. Level 7. Earthshine on the moon. When you look at a crescent moon and notice that you can faintly see the dark portion, the part not directly illuminated by the sun appearing as a ghostly, dim disk completing the full circle, you're witnessing Earthshine, which is sunlight that has bounced off Earth's clouds and oceans, traveled to the moon, reflected off the lunar surface, and then traveled back to your eyes in a double reflection that allows you to perceive features in what should be complete darkness. This effect is sometimes called the old moon in the new moon's arms, and it's most visible when the moon is a thin crescent, because that's when Earth appears nearly full from the lunar surface, maximizing the amount of reflected light available. From the moon's perspective, Earth is an extraordinarily bright object, about 50 times brighter than the full moon appears from Earth, because of our planet's higher reflectivity and larger angular size in the lunar sky. You are seeing Earth's reflected glory illuminating another world. The intensity of Earthshine varies depending on Earth's cloud cover and the reflectivity of the hemisphere facing the moon at any given time. Level 8. Venus burns. Hotter than Mercury. Venus maintains a surface temperature of approximately 475 degrees Celsius, 900 degrees Fahrenheit. Hot enough to melt lead, despite being nearly twice as far from the Sun as Mercury, which you'd intuitively expect to be hotter given its proximity to our star. But Mercury's thin atmosphere provides almost no insulation, allowing heat to radiate back into space, while Venus has become a runaway greenhouse effect nightmare with an atmosphere 90 times denser than Earth's, composed of 96% carbon dioxide wrapped in clouds of sulfuric acid that trap heat with devastating efficiency. This makes Venus the hottest planet in the solar system, even though Mercury receives more than twice the solar radiation. The Venusian atmosphere creates surface pressures equivalent to being 3,000 feet underwater on Earth, and the greenhouse effect is so extreme that there's virtually no temperature difference between the day side and night side, or between the equator and the poles. The entire planet maintains nearly uniform hellish conditions. Soviet Venera landers that reached the surface in the 1970s and 1980s survived less than 2 hours before the combination of heat and pressure destroyed them. Venus represents what unchecked atmospheric warming can eventually produce. Level 9. Saturn would float. If you could find a body of water large enough, an ocean of truly cosmic proportions, Saturn would float in it, because the planet's average density is roughly 0.687 grams per cubic centimeter, which is less than water's density of 1.0 gram per cubic centimeter, making Saturn the only planet in the solar system that could theoretically float if such an impossible experiment were possible. This counterintuitive property exists because Saturn is primarily composed of hydrogen and helium, the two lightest elements, in gaseous and liquid forms, with only a relatively small rocky core at the center, creating an overall density lower than water despite the planet's enormous mass of 95 Earth masses and a volume that could contain 764 Earths. The mental image of a planet-sized object floating breaks our terrestrial intuitions about how heavy things behave. But density, not mass, determines buoyancy, and Saturn's composition makes it genuinely less dense than water. The rings would obviously not float, being composed of ice and rock particles, but the gas giant itself would bob in an imaginary cosmic ocean. This fact reveals how different planetary composition can be from our Earth-based expectations. Level 10. Mars' sunset is blue. When the sun sets on Mars, the Martian sky near the sun turns blue, while the rest of the sky fades to a butterscotch or reddish hue, the exact opposite of Earth's red sunsets with blue skies, a reversal that occurs because of the fine dust particles suspended in Mars's thin atmosphere, which are just the right size to scatter blue light forward in the direction of the sun's rays, rather than scattering it in all directions, the way Earth's atmosphere scatters blue light across the entire sky. This means that on Mars, blue light becomes concentrated around the sun itself during sunset and sunrise, creating a localized blue glow that fades to red-orange as you look away from the sun, while during Martian daytime the sky appears butterscotch or tan because the dust particles scatter red light more efficiently across the dome of the sky. The Curiosity and Perseverance rovers have captured this phenomenon in photographs that look alien and backwards to human eyes accustomed to Earth's atmospheric optics. The effect becomes even more pronounced during dust storms, when suspended particles intensify the scattering. Looking at a Martian sunset photograph creates a cognitive dissonance because the color relationships feel inverted from every sunset you've witnessed in your life. Level 11. Olympus Mons Scale. The largest volcano in the solar system, Olympus Mons on Mars, stands roughly 13.6 miles high, nearly 3 times the height of Mount Everest. But if you were standing at its base preparing to climb it, you wouldn't see a mountain at all, just a gentle slope extending toward the horizon, because the volcano's base is so extraordinarily wide, approximately 370 miles across, that its gradient averages only about 5 degrees, creating a slope so gradual that you could climb it without realizing you were ascending a mountain until you'd walked for days and noticed the thinning atmosphere and the curvature of Mars visible below you. This challenges the fundamental concept of what a mountain is in human experience, where peaks are dramatic, visible, dominating features of the landscape. Olympus Mons is so massive that its summit would be in space by Earth atmospheric standards, yet its slopes are gentler than many wheelchair ramps. You could drive a car up most of it. The caldera at the summit, the collapsed volcanic crater, is 50 miles wide and could swallow the entire city of Los Angeles. Scale distorts recognition. Level 12. Diamond rain on Neptune. Deep within Neptune's atmosphere, roughly 5,000 miles below the visible cloud tops, the combination of extreme pressure, millions of times Earth's atmospheric pressure, and temperatures around 7,000 degrees Fahrenheit creates conditions that literally transform methane molecules into pure carbon, which then crystallizes into diamond fragments that rain downward through the planet's interior like a perpetual hailstorm of gemstones, potentially accumulating in a layer of liquid diamond ocean surrounding the rocky core, with solid diamond icebergs floating in it. This isn't speculation. Laboratory experiments have reproduced the conditions and confirmed that methane breaks down into diamond crystals under Neptune-like pressures and temperatures. The diamonds likely range from microscopic particles to chunks potentially weighing millions of carats, falling through hydrogen and helium atmospheres in a process that has continued for billions of years. Neptune and Uranus may contain more diamond mass than exists in all of Earth's deposits combined. The entire concept reframes precious gems as a common planetary interior phenomenon rather than rare geological accidents. What makes diamonds valuable on Earth is simply that our planet's interior conditions and geology don't produce them in abundance. Level 13. Your weight changes daily. Your weight fluctuates throughout the day, not just from food and water intake, but from the moon's gravitational pull, which is strong enough to raise ocean tides by dozens of feet, and also affects your body, though the effect is far more subtle. Roughly 0.0005% of your body weight, meaning if you weigh 150 pounds, the moon's gravity reduces or increases your weight by about 0.0007 pounds depending on its position relative to you, with the effect maximized when the moon is directly overhead or directly on the opposite side of Earth beneath your feet. Your bathroom scale would never register this tiny variation, but it's measurably real and affects everything on Earth's surface, not just water. The moon creates a slight stretching of Earth itself. The solid rock of the planet deforms by about 30 centimeters twice daily, following the same tidal forces that move the oceans. Your weight is not a fixed constant, but a variable that changes based on celestial mechanics, though the variation is far too small for human perception. Even the Sun contributes about half the tidal effect of the Moon, despite being much more massive, because tidal force depends on the gradient of gravity across distance, not absolute gravitational strength. Level 14. Seasons aren't about distance. The common misconception that summer occurs when Earth is closest to the Sun, and winter when Earth is farthest away, feels intuitively correct, but is completely backwards. Earth actually reaches perihelion, its closest approach to the Sun, in early January during the Northern Hemisphere's winter, and reaches aphelion, its farthest point, in early July during northern summer, proving that distance has almost nothing to do with seasonal temperature changes. The real cause is Earth's axial tilt of 23.5 degrees, which means that during northern summer, the northern hemisphere tilts toward the Sun, receiving more direct sunlight for longer periods each day, while 6 months later the same hemisphere tilts away, receiving oblique sunlight for shorter periods. This is why seasons are opposite in the northern and southern hemispheres. When it's summer in New York, it's winter in Sydney, despite both locations being the same distance from the Sun. The variation in Earth's distance from the Sun throughout the year is only about 3%, far too small to create the dramatic temperature swings of seasonal change. If distance were the primary factor, the entire planet would experience summer and winter simultaneously. Axial tilt, not orbital distance, creates the seasons you experience. Level 15. The Aurora's sound. The Aurora Borealis and Aurora Australis, the northern and southern lights, not only produce the famous shimmering curtains of green, red, and purple light, but also generate audible sounds that observers have reported for centuries, describing crackling, whooshing, or clapping noises that occur in sync with visible auroral movements. Though scientists remained skeptical of these accounts until recent decades, because the aurora occurs 60 to 200 miles above Earth's surface, far too high for sound to travel to ground level through the thin upper atmosphere. The current explanation involves electrostatic discharge. Powerful geomagnetic disturbances during intense auroral displays create separated layers of electrical charge in the atmosphere near ground level, which then discharge with audible cracks and snaps similar to static electricity, meaning you're not hearing the aurora itself, but a ground-level electrical phenomenon triggered by the same solar activity causing the lights. The sounds are rare and only occur during particularly intense geomagnetic storms when conditions align properly. Most aurora displays are completely silent, but when the sounds do occur, they're typically described as eerie and unsettling, adding an acoustic dimension to a primarily visual phenomenon that makes the experience more immersive and otherworldly. Level 16. Meteor versus Meteorite. The difference between a meteor and a meteorite is simply whether the object completed its journey to Earth's surface. The exact same piece of space debris has 3 different names, depending on where it is in its trajectory. When it's floating in space, it's a meteoroid. When it's burning through Earth's atmosphere, creating the bright streak you call a shooting star, it's a meteor. And if any fragment survives atmospheric entry and lands on the ground, that remnant becomes a meteorite. This naming convention means that language itself is location-dependent, with the object's identity changing based on its relationship to Earth rather than any intrinsic property of the material. Most meteors completely vaporize during atmospheric entry due to friction heating, never becoming meteorites, while only the largest meteoroids survive to impact the surface. You've probably seen thousands of meteors, shooting stars, but the odds of finding a meteorite are extraordinarily low unless you're specifically searching in desert or ice environments where they contrast with the landscape. The semantic distinction reveals how humans categorize celestial objects based on observational context rather than composition. What you call something depends entirely on where it happens to be at the moment you observe it. Level 17. The Moon is leaving. The Moon is currently receding from Earth at approximately 3.8 centimeters per year, roughly the same rate your fingernails grow. A process that has been measurably confirmed through laser ranging experiments where scientists bounce laser beams off reflectors that Apollo astronauts left on the lunar surface and precisely measure the time delay for the light to return, creating a multi-decade data set proving the Moon's gradual departure. This recession occurs because tidal interactions between Earth and the Moon transfer rotational energy from Earth's spin to the Moon's orbit, gradually slowing Earth's rotation while simultaneously pushing the Moon into a higher, more distant orbit. The same tidal forces that create ocean bulges are slowly pushing the Moon away. When the Moon first formed roughly 4.5 billion years ago from the debris of a Mars-sized impact, it orbited at about 15,000 miles from Earth compared to today's 240,000 miles, and Earth's day was only about 5 hours long. The recession will continue until tidal locking becomes mutual, both Earth and Moon showing the same face to each other eternally, though this equilibrium point won't be reached for billions of years. Eventually, the Moon will recede far enough that total solar eclipses become impossible. Level 18. Solar Eclipse. Coincidence. The fact that the Moon and Sun appear almost exactly the same angular size in Earth's sky, both subtending approximately 0.5 degrees, allowing for the perfect total solar eclipses where the Moon just barely covers the solar disk while revealing the corona, is an extraordinary cosmic coincidence with no physical reason to exist, purely an accident of the current moment in geological time. The Moon is 400 times smaller than the Sun, but also 400 times closer, creating this precise size match that won't last forever because of the Moon's recession. In the distant past, the Moon appeared much larger and created eclipses where it completely obscured the corona, while in the distant future, perhaps 600 million years from now, the Moon will appear too small to cover the Sun completely, making total solar eclipses impossible and leaving only annular eclipses where a ring of sunlight remains visible around the Moon's silhouette. You exist during an unimaginably brief window where perfect total solar eclipses occur. No other planet-moon combination in the solar system produces this effect. It's not designed or necessary, just an accident of timing that you happen to witness during the brief epoch when the scales balance perfectly. Level 19. The Milky Way's Invisibility. Most people living in developed areas have never seen the Milky Way, the galaxy they inhabit, because light pollution from cities and towns creates a sky glow that completely washes out the faint band of diffuse light from billions of distant stars that should be visible arcing across the night sky, meaning roughly 80% of North Americans and 60% of Europeans live under skies so bright that the Milky Way is completely invisible, effectively removing their most direct visual evidence of living inside a galaxy. This is a historically recent development. Every human who lived before the widespread adoption of electric lighting in the early 20th century could see the Milky Way on clear nights, making it a universal human experience for 300,000 years, that has now vanished for most of the modern world within just a few generations. Ancient myths and navigation systems were built around features of the night sky that most people today cannot perceive. When the 1994 Northridge earthquake knocked out power across Los Angeles, some residents called emergency services to report a strange, giant silvery cloud in the sky. They were seeing the Milky Way for the first time and didn't recognize their own galaxy. You live inside a structure you likely cannot see. Level 20. Retrograde motion illusion. When planets appear to reverse direction and move backwards against the background stars for weeks or months, an effect called retrograde motion that ancient astronomers found deeply puzzling and attributed to complex epicycle models where planets moved in circles within circles. You're witnessing a purely geometric illusion caused by Earth's own orbital motion overtaking slower outer planets, or being overtaken by faster inner planets, creating the appearance of backward movement in the same way that a car you're passing on the highway appears to move backwards relative to distant background objects, even though both vehicles are moving forward. Mars exhibits the most noticeable retrograde motion, appearing to move westward against the stars for about 72 days every 26 months, when Earth overtakes it in its orbit. And this regular reversal deeply troubled pre-Copernican astronomers who assumed Earth was stationary and struggled to explain why wandering stars would reverse course for no apparent reason. The Ptolemaic model with its epicycles was specifically designed to account for retrograde motion while maintaining Earth at the center of the cosmos. The illusion reveals how difficult it is to perceive the solar system's true geometry from within it, and how your brain defaults to interpreting your own motion as stillness, while attributing relative movement to external objects. Level 21. The Green Flash. At the exact moment the sun dips below the horizon during sunset, or emerges during sunrise, under specific atmospheric conditions involving a clear view to the horizon and minimal atmospheric turbulence, the very top edge of the sun's disk can flash brilliant green for roughly 1 to 2 seconds, an effect called the green flash that most people never witness in their lifetimes despite countless sunsets observed, because the conditions must align perfectly and you need to be watching the precise moment of disappearance with focused attention. The phenomenon occurs because Earth's atmosphere acts like a prism, refracting different wavelengths of sunlight by different amounts, with shorter wavelengths like blue and green bending more than longer wavelengths like red and orange. But blue light typically scatters too much to be visible, leaving green as the final color you see before the sun completely sets. It lasts only a blink. If you glance away or blink at the wrong moment, you miss it entirely. Jules Verne wrote about the green flash in his 1882 novel, describing it as a phenomenon that allows those who see it to read their own and others' hearts, cementing its status as a rare, almost mythical experience. The flash is more reliably visible from higher elevations or over ocean horizons, where atmospheric refraction is optimal. Level 22. Moon's gravity wells. The Moon's interior is not uniformly dense but contains mass concentrations called mascons, short for mass concentrations, which are regions of higher than average density buried beneath the lunar surface, primarily under large impact basins where asteroid strikes compressed and melted subsurface rock, creating localized gravitational anomalies strong enough to noticeably affect spacecraft orbits around the Moon. Apollo mission scientists discovered mascons when they noticed that lunar orbiters' trajectories were being perturbed in unexpected ways, with spacecraft speeding up slightly when passing over certain regions and slowing down over others, indicating that the Moon's gravitational field is lumpy rather than smooth. These buried mass concentrations create what are essentially gravity wells, invisible but measurable dips in the gravitational landscape that spacecraft fall into and climb out of during each orbit, gradually destabilizing low lunar orbits over time unless actively corrected with thruster burns. This is why there's no such thing as a stable low orbit around the Moon lasting more than a few months without propulsive corrections. The mascons eventually pull spacecraft into the surface. The Moon's gravitational field is more complex than Earth's despite the Moon's smaller size, because Earth's larger mass and ongoing geological activity have smoothed out many density variations. Level 23. Earth's hum. Earth produces a constant, low-frequency vibration, a barely detectable hum at frequencies between 2.9 and 4.5 MHz, far below the range of human hearing. That was first discovered in 1998, when seismologists analyzing data from seismic networks around the world noticed that their instruments detected a persistent background oscillation even during periods with no earthquakes, volcanoes, or other obvious sources of seismic activity. The planet is essentially ringing like a bell at all times, though the vibrations are so slow that each oscillation takes between 4 and 7 minutes to complete, creating a standing wave pattern where the entire planet expands and contracts by fractions of a millimeter in a complex pattern of overtones. The source of this mysterious hum remains partially debated, but the leading explanation involves ocean waves. Not the visible surface waves you observe at the beach, but deep ocean pressure fluctuations caused by opposing wave systems colliding, generating low-frequency pressure pulses that couple into the solid Earth and sustain the continuous vibration. You're standing on an instrument that never stops resonating, producing music you cannot hear, but that seismometers detect across every continent simultaneously. The hum is always present, always vibrating, an acoustic signature of the living planet. Level 24. Zodiac Shift. The zodiac, constellations that astrology uses to assign your sun sign based on your birth date, Aries, Taurus, Gemini, and so forth, are no longer aligned with the actual positions of the sun throughout the year due to a phenomenon called axial precession, where Earth's rotational axis slowly wobbles like a spinning top over a 26,000-year cycle, causing the position of the celestial poles and the vernal equinox to shift relative to the background stars. When the Babylonians established the zodiac around 2,000 years ago, the sun was indeed in Aries during late March and early April. But today, due to precession, the sun is actually in Pisces during those dates. The entire zodiac has shifted by roughly one constellation. This means if you were born under the sign of Leo according to traditional astrology, the sun was likely in Cancer at the time of your actual birth. Western astrology continues to use the tropical zodiac based on the seasons rather than the actual star positions, essentially ignoring the precession, while sidereal astrology used in Vedic traditions accounts for the shift. The constellations themselves haven't moved. Your frame of reference has rotated around them over millennia, creating a disconnect between ancient star lore and current astronomical reality. Level 25. The Overview Effect. Astronauts who view Earth from space frequently report experiencing a profound cognitive shift called the overview effect. A sense of awe, interconnectedness, and altered perspective that fundamentally changes how they understand humanity's place in the cosmos, describing the experience of seeing the planet as a fragile, borderless sphere suspended in the blackness of space. with the thin blue line of atmosphere appearing gossamer and delicate. All human conflicts and divisions suddenly seeming arbitrary and absurd when viewed from orbital distance. This isn't mystical or metaphorical, but a documented psychological phenomenon that appears to occur reliably across cultures, nationalities, and personalities when humans achieve sufficient distance to see Earth as an integrated whole, rather than the endless ground-level expanse we experience terrestrially. Astronauts describe realizing viscerally, not intellectually but emotionally, that national borders are invisible, that the atmosphere is shockingly thin, that everyone and everything they've ever known exists on that small blue marble. Frank White coined the term overview effect in 1987, after interviewing dozens of astronauts who struggled to articulate the transformation, but consistently reported a newfound sense of environmental stewardship and species-level identity. The experience represents a perceptual threshold that may only be crossable by physically leaving the planet and looking back. Perspective literally alters consciousness when scale changes dramatically enough. Rest point 1. Pause here for a moment. Let what you've heard settle. You've spent the last 25 levels discovering that your everyday experience of reality, stillness, starlight, sunsets, the moon, contains layers of strangeness you probably never noticed. If any of these have already shifted how you see the night sky or think about your place in space, subscribe so you don't miss what comes next. What you've heard so far is just the surface. The next 25 levels take you deeper into facts that break common sense entirely. Stay with me. Level 26. Time moves faster in space. Time is not a universal constant ticking at the same rate everywhere, but a flexible dimension that runs at different speeds depending on gravitational field strength. A phenomenon called gravitational time dilation, predicted by Einstein's general relativity and confirmed by extraordinarily precise atomic clocks, which show that time passes measurably faster in space than on Earth's surface because gravity literally warps space-time, slowing down time in stronger gravitational fields. GPS satellites orbiting 12,500 miles above Earth experience weaker gravity than you do standing on the surface, causing their onboard clocks to tick approximately 45 microseconds faster per day than identical clocks on the ground. A difference that seems negligible but would cause GPS positioning errors of several miles per day if engineers didn't continuously adjust for relativistic time dilation in the satellite's programming. Astronauts on the International Space Station age slightly faster than people on Earth, though the effect is measured in milliseconds over months in orbit. This isn't a measurement artifact or technical limitation, but a fundamental property of reality. Gravity slows time, and time genuinely runs at different rates in different locations. Your experience of time passing uniformly is an illusion created by living in an essentially uniform gravitational field. Climb a mountain and you age faster. Level 27. You're younger than your feet. Because time runs slower in stronger gravitational fields, and because your head experiences slightly weaker gravity than your feet by virtue of being farther from Earth's center, typically about 6 feet higher if you're standing, your head is aging faster than your feet by an infinitesimal but real amount, accumulating a time difference of roughly 90 billionths of a second over an 80-year lifespan, making the top of your body literally older than the bottom in a way that's not metaphorical but physically measurable with sufficiently precise atomic clocks. Scientists have verified this effect experimentally by placing synchronized atomic clocks at different heights, separated by as little as 1 meter, and detecting the predicted time dilation difference. The effect exists across any vertical distance in a gravitational field. Someone living on the top floor of a skyscraper ages faster than someone living on the ground floor, though the difference is far too small to affect biological processes or be perceptible in any practical sense. But it reveals something profound about the nature of time. It's not an external parameter that exists independently of space and matter, but an integrated part of space-time that responds to mass and energy. Your body doesn't experience a single uniform flow of time. Different parts of you exist in slightly different temporal streams, though the differences are negligible at human scales. Level 28. Neutron star density. A neutron star. The collapsed core remaining after a massive star explodes as a supernova, compresses roughly 1.4 times the mass of the Sun into a sphere only about 12 miles in diameter, creating matter so extraordinarily dense that a single teaspoon of neutron star material would weigh approximately 1 billion tons, or about the same mass as 900 Great Pyramids of Giza, compressed into a volume you could hold in your hand if the impossible gravitational forces didn't immediately destroy you and everything around you. This density exists at the very edge of what physics allows before matter collapses further into a black hole, with atomic nuclei crushed together so tightly that electrons merge with protons to form neutrons, creating essentially a giant atomic nucleus the size of a city. The surface gravity of a neutron star is approximately 200 billion times stronger than Earth's. If you somehow stood on one, you would be instantly flattened into a layer of atoms 1 atom thick, and even the mountains on a neutron star's surface, which are theoretically predicted to be fractions of a millimeter tall due to the extreme gravity, would weigh billions of tons. Neutron stars spin at hundreds of rotations per second, with some pulsars completing a full rotation in just milliseconds, despite being city-sized objects. The physics of neutron star interiors remains partially theoretical because we cannot recreate such extreme conditions in laboratories. Level 29. The Great Silence. The Fermi paradox captures the staggering contradiction between the high probability of extraterrestrial civilizations existing. The Milky Way contains roughly 200 billion stars, many with potentially habitable planets, and the galaxy is over 13 billion years old, providing ample time for intelligent life to evolve and spread, and the complete absence of any evidence for such civilizations. No radio signals, no visible megastructures, no self-replicating probes, nothing, creating what physicist Enrico Fermi summarized with the simple question, "Where is everybody?" when discussing this paradox over lunch in 1950. If intelligent life is common, and if technological civilizations develop the capability for interstellar travel or communication, then, even allowing for slow expansion at sub-light speeds, a single civilization could colonize the entire galaxy in just a few million years, a tiny fraction of the galaxy's age, meaning we should see evidence everywhere. Yet we observe complete silence. The possible explanations are all unsettling in different ways. Perhaps intelligent life is extraordinarily rare. Perhaps civilizations inevitably destroy themselves before becoming spacefaring. Perhaps advanced civilizations choose not to expand or communicate. Perhaps we're being deliberately avoided or observed. Or perhaps our assumptions about what constitutes detectable evidence are fundamentally wrong. The silence suggests something is filtering civilizations, either preventing them from arising or preventing them from expanding, and we don't know which side of that filter we're on. Level 30. Space is not empty. The vacuum of space, what you think of as perfect emptiness, the absence of matter between stars and galaxies, is not actually empty but seething with quantum activity, a roiling foam of virtual particles constantly popping into and out of existence in matter-antimatter pairs that exist for infinitesimally brief moments before annihilating each other, borrowing energy from the quantum vacuum for timescales so short that Heisenberg's uncertainty principle permits the transaction. This quantum foam means that empty space has an intrinsic energy density, sometimes called vacuum energy or zero-point energy, which physicists can measure through effects like the Casimir effect, where two uncharged metal plates placed extremely close together in a vacuum experience an attractive force, because the space between them excludes certain wavelengths of virtual particles, creating a pressure difference between the interior and exterior regions. Even in the deepest voids of intergalactic space, far from any matter or radiation, the quantum vacuum maintains this fundamental level of activity and energy. Space is not absence but a thing in itself, a dynamic quantum mechanical system with properties and behavior. The vacuum contains latent energy that would be catastrophically large if fully released. Cosmologists struggle to explain why the observed vacuum energy is 120 orders of magnitude smaller than quantum field theory predicts it should be, creating what's called the cosmological constant problem. Emptiness is not empty. Level 31. The Observable Universe. Limit. There is a fundamental horizon beyond which you can never observe the universe, not because of technological limitations or distance, but because of the finite speed of light combined with the universe's finite age. Light from regions beyond approximately 46 billion light-years away has not had sufficient time to reach Earth since the Big Bang occurred 13.8 billion years ago, creating an observational boundary called the cosmic light horizon that represents the edge of everything you could possibly see, even in principle with perfect instruments. This boundary exists in all directions equally, placing you at the center of your own observable universe. Though this is not a privileged position, every observer in the universe occupies the center of their own unique observable sphere, and the universe almost certainly extends far beyond what any individual observer can detect. What makes this more disturbing is that cosmic expansion is accelerating, meaning the observable universe is not growing to eventually encompass everything, but is actually shrinking in terms of what we'll be able to see in the future. Galaxies currently visible will recede beyond our cosmic horizon and disappear from view forever as space expands faster than light can traverse it. You will never see most of the universe, and the portion you can see is diminishing. There are galaxies whose light is reaching you right now for the last time. Level 32. Light Speed Barrier. The speed of light. 299,792,458 meters per second in vacuum. It's not just very fast, but represents an absolute cosmic speed limit that nothing with mass can reach. And this limitation is not an engineering challenge to overcome, but a fundamental property of spacetime itself, built into the structure of reality through the relationship between space, time, energy, and momentum described by special relativity. As an object with mass accelerates closer to light speed, its relativistic mass increases toward infinity, requiring infinite energy to actually reach light speed, making the barrier not just difficult but impossible to cross. You could accelerate a spacecraft using all the energy in the observable universe and still not quite reach light speed. This seems arbitrary until you understand that mass, energy, and the speed of light are connected through Einstein's famous equation E equals mc squared, revealing that the speed of light is really the conversion factor between mass and energy, a fundamental constant that defines how reality itself operates. Massless particles, like photons, must travel at light speed. They cannot go slower, while particles with mass must travel slower than light speed and cannot reach it. The barrier is not a suggestion or a technological limitation, but a structural property of space-time itself, as fundamental as the fact that you cannot travel north of the North Pole. Level 33. Black hole. Time. Stop. If you watched an object fall toward a black hole's event horizon, the boundary beyond which nothing, not even light, can escape, you would never actually see it cross that threshold, because, from your external perspective, gravitational time dilation becomes so extreme near the event horizon that time appears to slow to a complete stop, causing the falling object to appear frozen in place, red shifted toward invisibility as photons become increasingly stretched and delayed, asymptotically approaching the horizon for eternity without ever crossing it. From the falling object's perspective, however, nothing special happens at the event horizon. It crosses in finite time without noticing anything unusual at that exact moment, though it would then be doomed to reach the singularity at the black hole's center within seconds or minutes, depending on the black hole's size. This creates a paradox of perspectives. From outside, matter accumulates eternally at the event horizon, while from the infalling frame, it passes through and is destroyed. Both perspectives are equally valid within their own reference frames. The event horizon is not a physical surface or barrier, but a one-way membrane in space-time, a point of no return defined purely by geometry. The extreme time dilation means that from an outside observer's perspective, black holes effectively freeze time itself at their boundaries. Level 34. Cosmic microwave background. The static you see on an old analog television when tuned between channels, approximately 1% of that visual noise, is actually photons from the cosmic microwave background radiation, the leftover thermal glow from the Big Bang itself, cooled by cosmic expansion from the initial fireball of creation to a current temperature of 2.7 Kelvin, just a few degrees above absolute zero, filling all of space uniformly and providing a direct observable connection to the universe's origin 13.8 billion years ago. You are literally bathing in the afterglow of creation at every moment. Your body constantly bombarded by ancient photons that began their journey when the universe was only 380,000 years old, and opaque plasma finally cooled enough for light to travel freely. These photons have been traveling through space for over 13 billion years, red-shifted from visible light wavelengths to microwave wavelengths by the expansion of space itself. When you see television static, you're seeing history. Photons from the oldest light in the universe, the earliest moment we can observe, the cosmic baby picture. The cosmic microwave background is the most perfect black-body spectrum ever measured, almost impossibly uniform in all directions, with temperature variations of only 1 part in 100,000, revealing the universe's large-scale smoothness while containing the seeds of all future structure in its tiny fluctuations. Level 35. The missing antimatter. According to the fundamental symmetries of particle physics, the Big Bang should have created exactly equal amounts of matter and antimatter, particles and their oppositely charged counterparts, which should have completely annihilated each other in a burst of pure energy, leaving behind a universe containing only photons and no matter at all, meaning you should not exist, Earth should not exist. Stars and galaxies should not exist. Yet, obviously, the universe is filled with matter and contains almost no antimatter, indicating some kind of a symmetry or symmetry violation occurred in the first fraction of a second after the Big Bang that produced a slight excess of matter over antimatter. Current theories suggest there was approximately one extra matter particle for every billion matter-antimatter pairs, and when the annihilation finished, that tiny residue, 1/1000th of the original material, became everything you see in the universe today. The nature of this asymmetry remains one of physics' deepest unsolved problems, called the baryon asymmetry problem, because the known laws of physics don't predict enough asymmetry to explain the observed matter dominance. The universe should be empty radiation and isn't, suggesting the laws of physics contain subtle violations of symmetry that scientists haven't fully identified. Your existence is evidence of physics that haven't been completely understood. Level 36. Dark matter. Majority, approximately 85% of all matter in the universe is dark matter, a form of matter that doesn't interact with electromagnetic radiation, making it completely invisible to telescopes regardless of wavelength, detectable only through its gravitational effects on visible matter and light. And despite decades of intensive searching using increasingly sensitive detectors, scientists have never directly observed a single dark matter particle, leaving its fundamental nature a mystery. You know, dark matter exists because galaxies rotate too fast to be held together by only the visible matter they contain. Stars at the outer edges move so quickly that they should fling themselves into intergalactic space unless significantly more mass than we can see provides additional gravitational binding. Gravitational lensing observations, where massive objects bend light from background sources, reveal that galaxy clusters contain far more mass than can be accounted for by stars and gas. Computer simulations of cosmic structure formation can only reproduce the observed universe if they include roughly 6 times more dark matter than normal matter. Yet nobody knows what dark matter actually is. It could be exotic particles like WIMPs or axions, primordial black holes, or something entirely unexpected. The universe is dominated by a substance that remains unidentified, making everything you can see merely a small minority contaminant in a cosmos composed primarily of invisible material. Level 37. Rogue planets. Billions of planets drift through interstellar space completely untethered to any star. Rogue planets or free-floating planets ejected from their original solar systems through gravitational interactions during planetary formation, wandering the galaxy in permanent darkness, some potentially retaining heat from their formation or tidal interactions for billions of years, creating the possibility of subsurface oceans that could theoretically harbor life despite the planet's isolation in the cosmic void. Recent microlensing surveys suggest there may be more rogue planets in the Milky Way than there are stars, potentially trillions of orphaned worlds traveling alone through the darkness between solar systems, invisible except when they occasionally pass directly between Earth and a background star, briefly magnifying its light through gravitational lensing in events lasting hours to days. Some rogue planets were likely ejected during the chaotic early phases of solar system formation when planetary embryos scattered each other through close gravitational encounters, while others may have formed independently from collapsing gas clouds without ever orbiting a star. Jupiter and Saturn probably ejected dozens of planetary bodies during the solar system's youth, flinging them into interstellar space where they continue traveling today. Space is full of dark, frozen worlds you'll never see. outnumbering the planets that orbit stars, forever traveling through the void. Level 38, the cosmic web. Galaxies are not randomly distributed through space but organized into an immense cosmic web structure. Long filaments of galaxies separated by enormous voids, creating a pattern that resembles biological neural networks or soap bubbles, with matter concentrated along the threads and nodes while vast empty regions occupy the interior spaces, spanning billions of light years and representing the largest known structures in the universe. This web-like pattern emerged from tiny quantum fluctuations in the density of the early universe, amplified by billions of years of gravitational attraction as matter flowed from less dense regions into denser ones, creating a hierarchy of structure from individual galaxies to galaxy groups to galaxy clusters to superclusters to the filaments connecting them. The voids between filaments are not completely empty, but contain far fewer galaxies than average, making them relative deserts in the cosmic landscape. Mapping projects like the Sloan Digital Sky Survey have revealed this structure across billions of light years, showing that the universe's large-scale organization follows predictable patterns determined by gravity and dark matter acting over cosmic time. The Milky Way resides within the local group, which is part of the Virgo supercluster, which connects to other superclusters via filaments extending across hundreds of millions of light years. Structure exists at every scale you examine. Level 39. Gravitational lensing. Massive objects like galaxies and galaxy clusters don't just attract matter through gravity, but literally bend the fabric of space-time itself, creating curvature that affects the path of light passing near them, causing background objects to appear distorted, magnified, or multiply-imaged in an effect called gravitational lensing, that functions like a cosmic magnifying glass, allowing astronomers to observe extremely distant objects that would otherwise be too faint to detect. Einstein predicted this effect in 1915 as a consequence of general relativity, and Arthur Eddington first observed it during the 1919 solar eclipse when stars near the Sun's position appeared slightly displaced from their true locations due to the Sun's gravitational field bending their light. Strong gravitational lensing can create Einstein rings, perfect circles of light formed when a foreground galaxy precisely aligns with a background source, while weak lensing creates subtle distortions across large regions of sky that reveal the distribution of dark matter based on how it warps the apparent shapes of distant galaxies. The effect is not an optical illusion, but actual space-time curvature. Massive objects create dimples in the fabric of reality, and light follows the curved paths through that warped geometry. Gravitational lensing has become one of astronomy's most powerful tools, allowing observations of galaxies that existed when the universe was less than 1 billion years old. Level 40. Quantum entanglement. When two particles interact in certain ways, they can become quantum entangled, connected in a manner where measuring the state of one particle instantaneously determines the state of the other, regardless of the distance separating them, even if they're on opposite sides of the universe, creating what Einstein called spooky action at a distance, because it appears to involve faster-than-light influence that should violate relativity, though the effect has been experimentally verified thousands of times and represents a fundamental property of quantum mechanics rather than a flaw in the theory. The entanglement doesn't transmit information faster than light. You cannot use it to send messages because the measurement results appear random at each location individually, and only when you compare results do you notice the perfect correlation, requiring classical communication that respects the light speed limit. What makes this disturbing is that it suggests particles don't have definite states until measured, but exist in quantum superposition, and the act of measuring one particle somehow collapses the superposition for both simultaneously, as if the universe maintains a connection between entangled particles that transcends space. Entanglement has been demonstrated across distances exceeding 1,200 kilometers using satellites, and it's now being exploited for quantum computing and quantum cryptography. Reality at the quantum level operates according to rules that directly contradict our macroscopic intuitions about locality and separability. Level 41. The Axis of Evil. The cosmic microwave background radiation, the afterglow of the Big Bang, should be almost perfectly uniform in all directions because the early universe was extremely homogeneous, with only tiny random fluctuations in density and temperature. Yet, when scientists map the CMB in detail, they find a mysterious large-scale pattern where certain features seem aligned along a preferred axis running through the cosmos, creating what cosmologists somewhat dramatically call the axis of evil, because it shouldn't exist according to standard cosmological theory, which predicts statistical isotropy. The alignment appears in the quadrupole and octupole moments of the CMB temperature fluctuations, showing correlations that have less than a 1% probability of occurring by chance if the universe were truly isotropic. And the axis roughly aligns with the ecliptic plane of the solar system, which is deeply suspicious and suggests either a systematic error in the measurements, some unknown foreground contamination, or a genuine violation of the cosmological principle that the universe has no preferred directions. Multiple satellite missions, including WMAP and Planck, have confirmed the anomaly, ruling out most instrumental explanations, leaving cosmologists uncertain whether this represents new physics, a statistical fluke, or subtle contamination that hasn't been properly removed. The universe may have a preferred orientation, which would overturn fundamental assumptions about cosmic homogeneity. Level 42. Cold welding. When two pieces of the same metal touch each other in the vacuum of space, where there's no oxide layer or atmospheric contamination separating them, they can spontaneously fuse together at the molecular level in a process called cold welding or contact welding, which occurs because the metal atoms at the surfaces cannot distinguish between atoms from one piece versus the other, and simply bond together as if they were always part of the same continuous piece of metal, creating a permanent weld without any heat or external energy input beyond the initial contact pressure. This phenomenon caused significant problems during early space missions, when engineers discovered that metal components could unexpectedly stick together. And it's why spacecraft mechanisms requiring metal-on-metal sliding contact use special coatings or dissimilar metals to prevent cold welding. On Earth, this doesn't happen because atmospheric oxygen immediately forms thin oxide layers on metal surfaces, and water vapor deposits molecular films that prevent direct metal-to-metal contact. But in vacuum, those protective barriers don't exist, leaving the fresh metal surfaces exposed. The effect demonstrates how much of our intuition about how materials behave is actually specific to Earth's oxidizing atmosphere rather than being universal properties of matter. In vacuum, metals remember they want to be together. The atomic bonds reform instantly when given the opportunity, treating separate pieces as artificially divided portions of a single whole. Level 43. Vacuum boiling. If you placed a glass of water in the vacuum of space, it would simultaneously boil and freeze. The surface would rapidly boil away, as the lack of atmospheric pressure allows water molecules to escape into vapor at any temperature, while the evaporative cooling from this rapid boiling would simultaneously freeze the remaining liquid into ice, creating the paradoxical sight of ice with vapor streaming off it, violating the everyday expectation that things either freeze or boil, but not both at once. This occurs because boiling point and freezing point both depend on pressure, and at the extremely low pressures of vacuum, essentially 0 atmospheres, water's boiling point drops below its freezing point, creating conditions where liquid water cannot stably exist and must transition directly into ice and vapor. The triple point of water occurs at 0.01 degrees Celsius and 0.006 atmospheres, representing the only temperature and pressure where ice, liquid water, and water vapor can coexist in equilibrium, and vacuum conditions fall far below that pressure threshold. Astronauts who experienced accidental depressurization have reported saliva boiling on their tongues in the few seconds before losing consciousness, though the evaporative cooling prevents the boiling from causing thermal burns. Your intuitions about phase transitions break down completely outside Earth's comfortable atmospheric pressure, revealing how terrestrially specific your experience of basic physics really is. Level 44. The Zone of Avoidance. There's a region of the universe you can never optically observe from Earth. Approximately 20% of the entire sky is blocked from view by the Milky Way's own disk, which contains dense clouds of dust and gas that absorb visible light from more distant galaxies lying in those directions, creating a zone of avoidance where astronomers have almost no information about what lies beyond our galaxy's obscuring matter. This creates a serious observational blind spot in cosmology, because you cannot map the universe's large-scale structure without knowing what exists in those hidden regions, which could contain anything from normal galaxy distributions to massive clusters that significantly affect local gravitational dynamics. Radio and infrared wavelengths can partially penetrate the obscuring dust, allowing some observations of the zone of avoidance, and these surveys have discovered previously unknown galaxy clusters hidden behind the Milky Way's disk, including the massive Vela supercluster, which was only detected in the 1970s despite its relative proximity. The Great Attractor, a gravitational anomaly pulling the local group and thousands of other galaxies toward a region in the zone of avoidance, remains partially mysterious precisely because the Milky Way blocks direct observation of that area. Your cosmic knowledge contains a permanent gap determined entirely by your viewing location inside an obscuring galaxy. Level 45. Cosmic rays, flip elections. High-energy particles from space, called cosmic rays, primarily protons and atomic nuclei, accelerated to near-light speed by supernovae, pulsars, and other violent cosmic events, constantly bombard Earth from all directions, and when they strike computer memory chips, they can flip individual bits from 0 to 1 or vice versa, causing random errors that have affected everything from video game glitches to aircraft avionics, to at least one documented case where a cosmic ray strike altered the vote count in a Belgian electronic voting machine during a 2003 election, giving one candidate 4,096 extra votes, exactly 2 to the 12th power, indicating a single-bit flip in the vote counter. These soft errors or single-event upsets occur regularly in unshielded electronics, with cosmic ray-induced bit flips happening millions of times per day across all the computers on Earth, though error-correcting memory and redundancy systems catch most of them before they cause noticeable problems. Spacecraft and aircraft face higher cosmic ray exposure because they operate above most of Earth's protective atmosphere, requiring special radiation-hardened components. The fact that random particles from ancient supernovae can directly affect election outcomes or crash airplanes represents an unusually concrete example of how cosmic phenomena reach down into everyday life in unexpected ways. Space is not a distant abstraction, but actively interfering with your electronics right now. You're being bombarded constantly. Level 46. The Impossible Early Galaxies. The James Webb Space Telescope, launched in 2021, immediately began discovering massive, well-developed galaxies that existed when the universe was only a few 100 million years old, far earlier than cosmological models predicted such large, structured galaxies could have formed, creating what astronomers call the impossibly early galaxy problem, where observations directly contradict theoretical timelines for how quickly matter should have been able to clump together under gravity to build galaxy-scale structures. Some of these early galaxies appear to contain billions of stars and show signs of chemical enrichment that should require multiple generations of stellar evolution. Yet they existed when the universe was supposedly too young for such complexity. The standard lambda-CDM cosmological model, which has successfully explained most cosmic observations, struggles to account for how these galaxies assembled so quickly, suggesting either that current theories about dark matter, star formation efficiency, or early universe conditions need revision, or that some new physics operated in the first few 100 million years after the Big Bang. The discoveries are too recent and too new for consensus explanations to have emerged, leaving cosmologists in the uncomfortable position of having robust observations that don't match the theoretical framework. You're watching science work in real time. Paradigms confronting evidence that doesn't fit. Level 47. The Hubble tension. When astronomers measure the current expansion rate of the universe, a number called the Hubble constant that describes how fast space is stretching, they get significantly different answers depending on which measurement method they use, creating what cosmologists call the Hubble tension, a persistent disagreement between local measurements based on standard candles like Cepheid variables and Type 1a supernovae, which yield approximately 73 kilometers per second per megaparsec, versus measurements from the cosmic microwave background radiation combined with the standard cosmological model, which predict approximately 67 kilometers per second per megaparsec. This 9% discrepancy vastly exceeds the measurement uncertainties, and it persists even as observations become more precise, suggesting not random error, but a genuine conflict indicating either systematic errors nobody has identified or new physics that modifies how the universe expands at different epochs or scales. The tension has grown more acute over the past decade rather than resolving, with multiple independent measurement techniques confirming both values within their respective frameworks, meaning something fundamental is wrong with either the measurements, the cosmological models, or the underlying physics. Possible explanations include early dark energy, variations in dark matter properties, or unknown features of cosmic expansion. But none has gained consensus acceptance. The universe's expansion rate, one of cosmology's most fundamental parameters, remains uncertain despite decades of refinement. Level 48. Moon dust smell. After lunar surface excursions, Apollo astronauts consistently reported that moon dust, the fine regolith tracked into the lunar module on their spacesuits, smelled distinctly like spent gunpowder or fireworks, a sharp, acrid, metallic odor that surprised everyone because the moon is airless and the dust had been exposed to vacuum. Yet, once inside the pressurized cabin, the smell became immediately noticeable and memorable. The exact cause remains debated, with leading theories suggesting that the odor results from chemical reactions occurring when the lunar regolith, which has been continuously altered by solar wind and micrometeorite bombardment for billions of years in vacuum, suddenly encounters oxygen and moisture in the lunar module's atmosphere, triggering oxidation reactions that release volatile compounds detected by human olfactory receptors. Lunar dust is chemically reactive in ways that Earth soil is not, because terrestrial materials have already reacted with atmosphere and water, reaching chemical equilibrium, while lunar regolith remains in an energetically excited state, essentially waiting to react. Another theory proposes that the smell comes from ozone or other molecules created when high-energy particles destroy complex organic compounds in the astronauts' bodies, though this seems less likely. You cannot smell in vacuum, but when vacuum-exposed materials encounter atmosphere, they can release unexpected odors from reactions that have been waiting billions of years to occur. Level 49. The Sun's Missing Neutrinos. For decades, solar neutrino detectors on Earth consistently measured only about one-third the number of neutrinos that theoretical models predicted the Sun should be producing through nuclear fusion in its core, creating the solar neutrino problem that suggested either solar physics was fundamentally wrong, meaning scientists didn't understand how the Sun generates energy, or particle physics was incomplete in ways that allowed neutrinos to change type or disappear during their journey from the Sun's core to Earth. The discrepancy persisted across multiple experiments using different detection methods, all showing the same deficit, until physicists discovered that neutrinos can oscillate between three different types or flavors: electron, muon, and tau neutrinos, as they travel through space, and early detectors only measured electron neutrinos while missing the others, meaning the total neutrino count matched predictions, but the distribution across flavors changed. This discovery proved that neutrinos have mass. They must have mass to oscillate between types, contradicting the standard model of particle physics, which predicted massless neutrinos, requiring extensions to fundamental physics that scientists are still working to fully understand. The resolution of the solar neutrino problem simultaneously validated solar models while overturning assumptions about elementary particles. Sometimes the problem is not with the universe, but with the limited ways you're observing it. Level 50. Quantum tunneling stars. Nuclear fusion in the Sun's core, the process that powers the star and allows it to shine, should be impossible according to classical physics because the temperatures and pressures at the Sun's center, while extreme by everyday standards at 15 million Kelvin and 265 billion atmospheres, are insufficient to overcome the electromagnetic repulsion between positively charged protons trying to fuse together, creating an energy barrier that classical particles simply cannot cross. Yet, fusion occurs anyway, because protons are quantum particles that exhibit wave-like properties, allowing them to quantum tunnel through the energy barrier, essentially appearing on the other side without having enough energy to classically cross the barrier, with a probability low enough that any individual collision is unlikely to result in fusion, but high enough that with the enormous number of collisions occurring every second in the Sun's core, fusion happens at a rate sufficient to power the star for billions of years. Without quantum tunneling, stars could not exist. The universe would contain only cold hydrogen clouds that never ignite, and you would not be here to observe any of this. The Sun shines because particles can teleport through energy barriers they shouldn't be able to cross, exploiting fundamental quantum uncertainty to violate what appears to be an insurmountable obstacle. Classical physics would create a cold, dead cosmos. Quantum mechanics makes stars possible. Deep bridge. You've just spent 50 levels moving from everyday observations to facts that actively break common sense. Starlight that's already old when it reaches you. Time running at different speeds depending on where you stand. Matter that simultaneously boils and freezes. The universe's expansion rate contradicting itself depending on how you measure it. These aren't abstractions or thought experiments. They're verified phenomena that reveal how radically different reality is from your evolved intuitions about how things should work. What comes next goes deeper still, but the nature of the challenge changes. The first 50 levels dealt with counterintuitive physics, things that break your expectations but remain comprehensible once explained. The next 25 move into cosmic scale territory, where the challenge isn't just understanding the mechanism, but grasping magnitudes that exceed human cognitive capacity entirely. You're about to encounter numbers and timescales that your brain cannot truly process, distances that cannot be visualized, structures so vast that describing them feels more like incantation than explanation. This isn't meant to frighten you or make you feel small, though it may do both. It's meant to recalibrate your sense of scale, to give you some contact, however abstract, with the actual dimensions of the universe you inhabit. The facts remain facts regardless of whether they're comfortable. The cosmos doesn't care if you can comprehend it, but offering you the chance to try feels important. If you've made it this far, you're not a casual listener. Subscribe if you haven't already. This is where it starts getting really interesting, where we move from mind-bending to genuinely incomprehensible. What follows requires you to abandon any expectation that human intuition will guide you correctly. The universe operates at scales where your evolved perceptual systems have no reference points. That's not a failure on your part. It's just the reality of being a small pattern of organized matter, trying to understand structures millions of times larger and older than your entire species. Stay with me. Let's see how far scale can stretch before understanding breaks completely. Level 51. The Great Attractor. Something enormous is pulling the Milky Way and thousands of neighboring galaxies toward a region of space approximately 250 million light-years away, in the direction of the Hydra and Centaurus constellations at roughly 600 kilometers per second. A gravitational anomaly so massive that it's drawing not just individual galaxies, but entire galaxy clusters toward it, overriding the cosmic expansion that should be pushing everything apart. Yet, when astronomers look in that direction, they cannot fully see what's causing the attraction because it lies partially behind the Milky Way's disk in the zone of avoidance where dust obscures the view. The mass required to produce such powerful gravitational pull across such vast distances is roughly equivalent to tens of thousands of Milky Way-sized galaxies, concentrated in a region dominated by a structure called the Norma cluster, though some of the apparent motion toward the Great Attractor may actually be caused by an even larger structure beyond it called the Shapley supercluster, creating a gravitational hierarchy where you're being pulled toward something being pulled toward something else. Your galaxy is falling toward an immense concentration of mass that you cannot clearly observe, and this motion has continued for hundreds of millions of years, carrying you through space at speeds you cannot feel toward a destination you cannot see. Everything around you is being drawn toward a partially hidden mass concentration. Level 52. Supermassive black holes. At the center of nearly every large galaxy, including the Milky Way, resides a supermassive black hole containing millions to billions of times the mass of the Sun compressed into a region smaller than the solar system. Objects so massive and gravitationally dominant that they anchor entire galaxies while remaining invisible except through their effects on nearby matter, which spirals inward, forming superheated accretion disks that can outshine all the stars in the galaxy combined. The supermassive black hole at the Milky Way's center, called Sagittarius A star, pronounced Sagittarius A star, contains approximately 4.3 million solar masses within an event horizon roughly 12 million miles in diameter. And astronomers have directly observed individual stars orbiting this invisible object at speeds up to 5,000 kilometers per second, completing full orbits in as little as 16 years, despite the orbital distances being billions of miles. How supermassive black holes formed remains partially mysterious. They appear to exist even in the earliest galaxies, suggesting they grew extremely rapidly in the universe's youth, or formed through mechanisms different from stellar mass black holes created by supernova collapse. The black hole at the center of the galaxy M87 contains 6.5 billion solar masses, and was the first black hole ever directly imaged through its silhouette against the surrounding accretion disk. You orbit one of these objects, circling the galactic center every 225 million years, your entire solar system held in gravitational thrall to an invisible anchor. Level 53. Magnetar Terror. Magnetars are neutron stars with magnetic fields approximately 1,000 trillion times stronger than Earth's magnetic field, the most powerful magnetic fields known to exist in the universe, strong enough that they warp the quantum vacuum itself, create mountains in the neutron star's crust that are fractions of a millimeter tall, but contain the mass of mountains, and would kill you instantly from a distance of 600 miles away, not through radiation or gravity, but purely through the magnetic field's interaction with the electromagnetic structure of your atoms, literally disrupting the atomic bonds that hold your molecules together. A magnetar within 1,000 kilometers would erase the information on every credit card, hard drive, and magnetic storage device on Earth, while potentially damaging cellular structures through induced electrical currents. When magnetars experience starquakes, sudden cracking and reorganization of their ultra-dense crusts, they release gamma-ray bursts detectable across the galaxy. And one such burst from a magnetar 50,000 light-years away in 2004 measurably affected Earth's ionosphere despite the immense distance. The magnetic field strength is so extreme that quantum electrodynamic effects become important. The vacuum itself becomes birefringent, splitting light into polarization components that travel at different speeds. Physics breaks down under these conditions in ways that make the behavior genuinely difficult to predict. Magnetars represent the universe's most extreme magnetic environments by orders of magnitude. Level 54. Gamma-ray bursts. Gamma-ray bursts are the most energetic electromagnetic events in the universe. Explosions that release in seconds more energy than the sun will produce in its entire 10 billion-year lifetime. Thought to be created either by hypernova explosions of extremely massive stars collapsing into black holes or by neutron star mergers, focusing their energy into tight beams that sweep across space like cosmic lighthouse beams, temporarily outshining every other gamma-ray source in the observable universe combined. If a gamma-ray burst occurred within a few thousand light-years of Earth, and its beam happened to be pointed in our direction, the radiation would strip away the ozone layer, causing mass extinction through ultraviolet exposure and disrupting the food chain at its photosynthetic foundation. Though fortunately, such events are extraordinarily rare, and most occur in galaxies millions or billions of light-years distant. The detected bursts arrive from random directions with no warning, representing explosions that occurred when the light began its journey eons ago. You're seeing ancient catastrophes that destroyed entire stellar systems long before Earth existed. A typical long gamma-ray burst releases approximately 10 to the power of 44 joules of energy, which is roughly equivalent to converting the mass of several suns entirely into electromagnetic radiation, following Einstein's E equals mc squared. The universe is capable of violence at energy scales that make supernovae seem gentle by comparison. These are not mere stellar deaths, but cosmic cataclysms. Level 55. The Boötes Void. There exists a region of space approximately 330 million light-years in diameter, containing only about 60 galaxies, where normal space of that volume should contain roughly 2,000 galaxies. A cosmic void so underdense compared to average regions of the universe that it's called the Boötes Void, or the Great Nothing. Discovered in 1981 when astronomers surveyed galaxy distributions and found this enormous bubble of near emptiness occupying a significant fraction of the observable universe in the direction of the Boötes constellation. The void is not completely empty, but is more than 95% underdense compared to typical cosmic structure, and its existence on such a large scale challenges aspects of cosmological models, because creating such a large underdense region requires matter to have evacuated that volume and concentrated elsewhere, implying very large-scale coherent flows and structure formation processes operating across hundreds of millions of light-years. The void's galaxies appear to be concentrated in a thin shell around the perimeter, as if matter slid toward the edges and left the interior hollow. You can point to a region of sky and know that in that direction lies mostly nothing for distances spanning hundreds of millions of light-years. True cosmic emptiness. A volume so vast that light takes 1/3 of a billion years to cross it, and almost nothing exists there. The universe is not uniformly distributed, but contains desert regions approaching absolute vacancy. Level 56. Quasar. Power. Quasars, quasi-stellar objects, are the brightest continuously luminous objects in the universe, powered by supermassive black holes actively consuming matter at prodigious rates, converting gravitational potential energy into radiation so efficiently that a single quasar can outshine an entire galaxy containing hundreds of billions of stars while remaining point-like in appearance. Because all that luminosity emerges from a region only light hours across, smaller than the solar system, yet brighter than the Milky Way. The brightest known quasars have luminosities exceeding 10 to the power of 41 watts, which is roughly 100 trillion times the Sun's power output, sustained by black holes consuming matter equivalent to hundreds of Earth masses per year, with the infalling matter reaching temperatures of millions of degrees as it spirals inward through the accretion disk, emitting across the entire electromagnetic spectrum from radio waves to gamma rays. Quasars were far more common in the early universe, with peak quasar activity occurring when the cosmos was 2 to 3 billion years old. And most quasars visible today are billions of light-years distant, meaning you're observing the universe's youth when supermassive black holes were still actively feeding and galaxies were still assembling. The quasar era represents a violent, energetic phase of cosmic evolution that has mostly ended. Local supermassive black holes have consumed most available nearby matter and entered dormancy. You're looking at ancient feeding frenzies frozen in light from epochs long past. Level 57. The Cosmic Calendar. If you compress the entire 13.8 billion-year history of the universe into a single calendar year, with the Big Bang occurring at the first moment of January 1st and the present moment arriving at midnight on December 31st. Then the Milky Way forms around mid-March. The Sun and Earth appear in early September. The first simple life emerges in late September. Photosynthesis begins in early October. Complex multicellular life doesn't appear until mid-December. Dinosaurs rule from December 25th to December 30th. Humans evolve in the last hour of December 31st. All of recorded human history occupies the final 10 seconds of the year, and the entire span of your individual life compresses into a small fraction of the last second before midnight. This scale compression reveals the incomprehensible vastness of cosmic time relative to human experience. You exist for a blink within a blink at the very end of a story that has been unfolding for durations your mind cannot genuinely process. The pyramids were built 3 seconds ago on this scale. Agriculture began 7 seconds ago. The Roman Empire rose and fell within the last second. Everything you think of as ancient human history clusters in a tiny fraction of the cosmic year's final moment, while vast stretches of time elapsed during which stars formed, burned, and died in generation after generation, building the heavy elements that eventually became your body through processes requiring billions of years. Level 58. Deep Time. Perspective. The Stegosaurus, which lived approximately 150 million years ago during the late Jurassic period, is temporally closer to you than it was to the Tyrannosaurus rex, which lived approximately 68 million years ago during the late Cretaceous. Roughly 82 million years separate Stegosaurus and T. rex, while only 68 million years separate T. rex from the present day. Meaning, when T. rex walked the Earth, Stegosaurus fossils were already ancient, buried in rock layers tens of millions of years old. This reveals how your intuitive sense of the age of dinosaurs as a single unified period compresses and distorts genuine deep time, creating the illusion that all dinosaurs were contemporaries when in fact the dinosaur era spanned more than 165 million years, during which continents drifted, climates shifted dramatically, and entire ecosystems rose and fell in succession. Trilobites, which went extinct in the Permian mass extinction 252 million years ago, existed for roughly 270 million years, longer than the entire span from their extinction to the present. And most of that vast duration predates any land vertebrates whatsoever. Your species has existed for roughly 300,000 years, which is 1/8 of 1% of the time trilobites existed, and modern Homo sapiens have only been anatomically modern for about 200,000 years. Deep time operates at scales where millions of years become casual units of measurement, and human history compresses to invisibility. Level 59. The Last Star. Star formation in the universe cannot continue forever because it requires a supply of hydrogen gas that is slowly but inexorably being converted into heavier elements and locked up in stellar remnants, brown dwarfs, and planets, with current estimates suggesting the last star capable of fusion will form approximately 100 trillion years from now. An almost incomprehensible span roughly 7,000 times longer than the current age of the universe, after which no new stars will ever ignite, and the cosmos will enter the degenerate era, where stellar remnants, brown dwarfs, and rogue planets drift through expanding space, gradually cooling toward absolute zero. The smallest red dwarf stars can burn for trillions of years, far longer than the current age of the universe, meaning most red dwarfs that exist today will still be shining long after the sun has exhausted its fuel and become a white dwarf. and these long-lived stars will be the last sources of light in the cosmos before darkness becomes permanent. Eventually, even white dwarfs will cool to become black dwarfs, cold, dead stellar remnants that emit no light. Though this process takes so long that no black dwarfs exist yet anywhere in the universe because insufficient time has elapsed since the Big Bang. You exist during the stelliferous era when star formation remains active and the universe is still young and bright. But this is a temporary condition. The future is almost entirely darkness, with a few brief, bright epochs near the beginning. You're witnessing the universe in its youth. Level 60. Galactic Collisions. The Andromeda Galaxy, currently approximately 2.5 million light-years away and visible as a faint smudge in the night sky, is approaching the Milky Way at roughly 110 kilometers per second, meaning in approximately 4 to 5 billion years, the two galaxies will collide and merge into a single elliptical galaxy, sometimes called Milkometa, gravitationally disrupting both galactic structures, scattering stars into new orbits, potentially triggering massive bursts of star formation as gas clouds collide and compress, and likely ejecting the solar system from the galactic core region into the outer halo or potentially into intergalactic space entirely. Despite containing hundreds of billions of stars each, the actual stellar collision probability during galactic mergers remains extremely low because stars are separated by vast empty distances. The galaxies will pass through each other mostly without direct star-on-star impacts, like two swarms of gnats interpenetrating. But the gravitational interactions will reshape both systems completely, potentially feeding the central supermassive black holes, which may themselves merge into a single, even more massive black hole. Computer simulations show the collision occurring in multiple passes, as the galaxies swing past each other, lose energy to gravitational interactions, and spiral inward in a process lasting hundreds of millions of years before final merger. If humanity or its descendants still exist in 4 billion years, the night sky will be dramatically different, with Andromeda growing larger over millions of years until it dominates the sky, then fragmenting and stretching as tidal forces tear it apart before ultimate merger. The collision is already inevitable. The galaxies are gravitationally bound. Level 61. Hypervelocity stars. Some stars travel through the galaxy at speeds exceeding 1,000 kilometers per second, fast enough to escape the Milky Way's gravitational pull entirely, having been violently ejected from their original locations through gravitational slingshot interactions, typically involving close encounters with the supermassive black hole at the galactic center, or through the supernova explosion of a companion star in a binary system. And these hypervelocity stars are now fleeing into intergalactic space on one-way journeys that will eventually carry them millions of light-years from their galaxy of origin. The first hypervelocity star was discovered in 2005, and astronomers have since identified dozens more, some moving so fast they'll escape the local group entirely and spend eternity drifting through the void between galaxy clusters. These stellar refugees carry planetary systems with them. If any planets orbit hypervelocity stars, those worlds are being carried into cosmic exile, eventually finding themselves in intergalactic space where the night sky contains no nearby stars, only distant galaxy smudges separated by millions of light-years of emptiness. A civilization arising on such a planet would experience profound cosmic loneliness, surrounded by darkness with their parent star as the only nearby light source. The stars themselves travel for hundreds of millions of years, crossing distances that dwarf anything terrestrial experience can contextualize, carrying whatever matter accompanies them into the genuine void between galaxies. Level 62. The cold spot. Within the cosmic microwave background radiation, the nearly uniform afterglow of the Big Bang that fills all of space, there exists an anomalous region approximately 1.8 billion light-years across that is significantly cooler than the surrounding average temperature, called the CMB cold spot, which was first detected in 2004 and has resisted straightforward explanation because its size and temperature deficit are difficult to reconcile with the standard cosmological model's predictions about primordial temperature fluctuations. The spot is about 70 microkelvins colder than the average CMB temperature of 2.725 Kelvin, which seems trivial, but represents a statistical anomaly with less than 1% of probability of occurring randomly in the early universe's quantum fluctuations. Some theories suggest the cold spot could mark the location of an enormous cosmic void, a region unusually empty of galaxies, where photons passing through lose energy through the integrated Sachs-Wolf effect, while more exotic explanations propose it could be evidence of a parallel universe colliding with our own during cosmic inflation, leaving a lasting imprint in the microwave background. Most scientists favor prosaic explanations involving statistical flukes or unidentified systematic errors, but the cold spot remains suspicious precisely because it appears in what should be the most carefully analyzed and well-understood dataset in observational cosmology. Something created an anomalous temperature pattern across a region larger than 1,000 superclusters. Level 63. Cosmic voids. The majority of the universe's volume is genuinely empty space. Vast cosmic voids hundreds of millions of light-years across containing few or even no galaxies, separated by relatively thin filaments and walls where galaxies concentrate, creating a structure where most of space is vacuum, while most galaxies cluster along the boundaries between voids like soap bubbles pressed together. These voids occupy roughly 80% of the universe's volume, while containing less than 10% of its galaxies, meaning that most of space is genuinely empty in a way that goes beyond ordinary interstellar or intergalactic distances. These are region-scale vacuums where you could travel for hundreds of millions of light-years in any direction and encounter almost nothing. The voids formed through gravitational evolution as matter flowed out of underdense regions toward overdense regions over billions of years, evacuating the low-density volumes and concentrating along the walls, creating the cosmic web structure visible in large-scale galaxy surveys. Some voids contain literally zero galaxies across volumes that would typically house thousands, representing the closest thing to absolute emptiness that exists in the universe. If you were somehow placed in the center of a large void, distant galaxy clusters would be visible only as faint smudges near the horizon in every direction, separated by hundreds of millions of light-years, and the local environment would approach perfect vacuum extending in all directions for distances incomprehensible to human intuition. Level 64. The scale problem. If you scaled the Sun down to the size of a grain of sand, roughly 1 millimeter in diameter, then, on that same scale, Earth would be a microscopic speck about 1/10 of a millimeter across orbiting 10 centimeters away, and the nearest star, Proxima Centauri, would be another grain of sand approximately 4 miles distant, with the space between containing essentially nothing, creating a mental model where the solar system is mostly empty and the distances between stars are incomprehensibly vast, even when scaled down to tangible sizes. On this scale, the Milky Way galaxy would be roughly 8,000 miles in diameter, about the distance from New York to New Zealand, and would contain approximately 200 billion grains of sand scattered across that volume, most of them separated by miles of emptiness. The Andromeda Galaxy would be another collection of grains of sand located roughly 200,000 miles away, and the observable universe would extend about 800 million miles in all directions, containing roughly 2 trillion tiny sand grains representing galaxies, each containing hundreds of billions of even tinier grains representing stars. This scaling exercise reveals the fundamental truth that space is almost entirely empty. The distances between objects are staggeringly large compared to the sizes of the objects themselves, and most of the universe is vacuum punctuated by occasional tiny concentrations of matter. You live on a speck orbiting a grain of sand, isolated by distances that remain incomprehensible even when scaled to everyday units. Level 65. Light-year comprehension. A light year, the distance light travels in 1 year at 186,000 miles per second, equals approximately 5.88 trillion miles, or 9.46 trillion kilometers. A number so large it becomes essentially meaningless to human intuition. Yet astronomers use light years as casual units because they're convenient for expressing cosmic distances, and even traveling at light speed. The absolute maximum speed anything can achieve. You would still require 100,000 years to cross the Milky Way galaxy from edge to edge, 2.5 million years to reach the Andromeda Galaxy, and 13.8 billion years to approach the edge of the observable universe. Light that left the Andromeda Galaxy when your Australopithecine ancestors were just beginning to walk upright is only now arriving at Earth, and light leaving Earth right now won't reach Andromeda until long after your species will likely be extinct or transformed beyond recognition. The fastest human-made object, the Parker Solar Probe, travels at roughly 430,000 miles per hour at its peak speed, which sounds impressive until you realize that at that velocity it would still take approximately 7,000 years to travel 1 light year, and reaching Proxima Centauri, the nearest star at 4.24 light-years away, would require roughly 30,000 years of continuous travel. Interstellar distances are not merely large but prohibitively vast, creating isolation that may be fundamentally insurmountable for civilizations bound by the laws of physics as currently understood. Level 66. Proxima Centauri Journey. The nearest star to the Sun, Proxima Centauri, a small red dwarf located 4.24 light-years away in the Alpha Centauri system, is so distant that using current spacecraft technology, a journey there would take approximately 6,300 years at the speeds achieved by Voyager 1, humanity's fastest probe to leave the solar system, which travels at roughly 38,000 miles per hour relative to the Sun, yet would still require millennia to traverse the gulf separating solar systems. Proposed future technologies like Project Breakthrough Starshot, which would use powerful lasers to accelerate tiny gram-scale probes to 20% of light speed using light sails, could theoretically reduce the travel time to approximately 20 years. But such a mission would require technological capabilities far beyond current engineering, including lasers powerful enough to propel spacecraft yet precise enough to keep the beam focused across billions of miles, and the probes would be so small they could only carry minimal instruments and would have no capability to slow down upon arrival. Instead, flashing past the target star system at tens of thousands of miles per second, gathering data for mere hours during closest approach. Even our nearest stellar neighbor exists behind a barrier of distance that current technology makes effectively unreachable, and any civilization capable of routine interstellar travel would require either technologies that seem almost magical from the present perspective or generation ships where entire societies live and die during the journey spanning multiple human lifetimes. Level 67. Voyager's Progress. Voyager 1, launched in 1977 and now humanity's most distant object, has been traveling outward for over 47 years and is currently more than 15 billion miles from Earth, approximately 163 times the distance from Earth to the Sun. Yet, despite this enormous distance and nearly half a century of continuous travel at 38,000 miles per hour, it has not yet truly left the solar system's gravitational influence and won't reach the inner edge of the Oort cloud for approximately 300 years, won't exit the outer edge of the Oort cloud for another 30,000 years after that, and won't make a close approach to another star system for roughly 40,000 years, when it will pass within 1.6 light-years of the red dwarf star Gliese 445. The spacecraft's power supply, generated by decaying plutonium-238, will be exhausted by approximately 2025, after which Voyager 1 will go silent but continue coasting through space indefinitely, a human-made artifact carrying a golden record containing sounds and images from Earth, messages intended for any extraterrestrial intelligence that might eventually encounter it, though the probability of such an encounter in the vast emptiness of interstellar space approaches zero. Voyager 1 will drift through the galaxy for millions or billions of years, outlasting human civilization, potentially outlasting the Earth itself, a testament to a moment in the 20th century when a species briefly achieved the capability to fling objects beyond its own planetary system, creating something potentially immortal from a civilization that is certainly not. Level 68. The Oort cloud. The solar system doesn't end at Pluto or even at the heliopause where the solar wind meets interstellar space. It extends outward to the Oort cloud, a vast spherical shell of icy bodies and cometary nuclei surrounding the Sun at distances ranging from approximately 2,000 to 100,000 astronomical units, with the outer boundary located roughly halfway to Proxima Centauri, meaning the Sun's gravitational domain extends about 2 light-years in all directions, encompassing a volume containing trillions of objects that only occasionally get perturbed into the inner solar system, where they become visible as long-period comets. The Oort cloud has never been directly observed. It's too distant and its individual objects too small and faint. But its existence is inferred from the orbital characteristics of long-period comets, which arrive from random directions rather than from the ecliptic plane like short-period comets from the Kuiper belt, suggesting they originate from a spherical distribution rather than a disk. The cloud contains perhaps trillions of icy bodies, ranging from kilometer-sized to larger, representing primordial material from the solar system's formation 4.6 billion years ago. Gravitationally bound to the Sun, but so loosely that passing stars or galactic tides can occasionally perturb their orbits and send them sunward. The solar system is vastly larger than the planetary region, extending light-years into space as a diffuse cloud of frozen material gradually fading into the interstellar medium. What you think of as the solar system is just the bright inner core. Level 69. Galactic Year. The Sun, along with the entire solar system, orbits the center of the Milky Way galaxy at approximately 514,000 miles per hour, far faster than Earth orbits the Sun, completing one full galactic orbit every 225 to 250 million years, a timescale called a galactic year or cosmic year, meaning the Sun has completed roughly 20 orbits since its formation 4.6 billion years ago, and during each orbit, the solar system bobs up and down relative to the galactic plane, passing through the disk approximately every 30 million years. The last time the Sun was in its current position in its galactic orbit, dinosaurs had not yet evolved. The most advanced life forms were early reptiles and amphibians, and the supercontinent Pangaea was still forming, creating a temporal scale where galactic motion measures geological and evolutionary epochs rather than human history. One galactic year ago, the Permian period was ending in the largest mass extinction in Earth's history. 2 galactic years ago, animal life was just beginning to colonize land. The Sun's orbital velocity carries you through space far faster than Earth's orbital motion, but you feel none of it because the entire solar system moves together, maintaining relative stillness while racing around the galactic center at 500,000 miles per hour, swept along by gravitational forces operating on scales vastly larger than planetary or stellar systems. Level 70. The universe's age limit. You cannot observe the universe as it was during the first 380,000 years after the Big Bang, not because of technological limitations, but because the early universe was opaque, filled with a hot plasma of ionized hydrogen, where photons scattered continuously off free electrons and could not travel in straight lines, creating an era before the cosmic microwave background radiation was released, when light could not propagate freely through space. This creates an observational horizon called the surface of last scattering, representing the earliest moment the universe became transparent and light could begin traveling across cosmic distances. Everything before that epoch is hidden behind an opaque wall of plasma that no electromagnetic observation can penetrate, making the cosmic microwave background the oldest light you can ever observe, regardless of telescope technology or future scientific advances. To probe earlier times requires non-electromagnetic methods like gravitational wave astronomy or neutrino detection, which can potentially see further back because gravitational waves and neutrinos interact weakly with matter and could have escaped the opaque early universe. But photon-based observation reaches a fundamental limit at 380,000 years after the Big Bang. The first fraction of a second, when inflation occurred, when baryogenesis created the matter-antimatter asymmetry, when the fundamental forces separated, remains accessible only through indirect inference and theoretical modeling rather than direct observation. There's a wall in time you cannot see beyond, not yet, perhaps not ever. Level 71. Cosmic expansion speed. Distant galaxies are receding from Earth at speeds that increase with distance according to Hubble's law. For every megaparsec of distance, approximately 3.26 million light-years, the recession velocity increases by roughly 70 kilometers per second, meaning galaxies sufficiently far away are receding faster than the speed of light, which seems to violate special relativity's prohibition on faster-than-light travel but actually doesn't, because the galaxies aren't moving through space faster than light. Rather, space itself is expanding between them, carrying them apart, and general relativity places no limit on how fast space can expand. Galaxies beyond approximately 14 billion light-years are receding faster than light, meaning light leaving those galaxies now will never reach Earth because the space between us is expanding faster than the light can traverse it, creating a cosmological horizon beyond which events occurring now are forever unobservable. You can see those galaxies as they were in the past because their light was emitted when they were closer and the expansion rate was slower, but you cannot see them as they exist now and never will. The accelerating expansion driven by dark energy means this horizon is actually shrinking. Galaxies currently visible will eventually recede beyond the horizon and disappear from view permanently as expansion carries them past the threshold where light can no longer bridge the growing gulf. The universe is not only expanding, but the expansion is accelerating, and most of the cosmos is already receding faster than information can travel. Level 72. The particle horizon. The particle horizon represents the maximum distance from which light could have traveled to reach you since the Big Bang. Currently, approximately 46 billion light-years, despite the universe being only 13.8 billion years old, because cosmic expansion has stretched the space between the emission point and Earth during the light's journey, moving the original emission location much farther away than a simple calculation based on light travel time would suggest. This horizon defines the observable universe. Everything within the particle horizon is potentially observable given sufficient instrumental sensitivity, while anything beyond it is not merely difficult to observe, but fundamentally unobservable, because insufficient time has elapsed for light to traverse the distance, even accounting for cosmic expansion. The observable universe contains roughly 2 trillion galaxies within this horizon, but the total universe almost certainly extends far beyond, possibly infinitely far, meaning you occupy a bubble of observability surrounded by vast or infinite regions that are permanently and fundamentally beyond observation, not because of technological limitations, but because of the finite age of the universe and the finite speed of light. Every observer in the universe occupies the center of their own observable sphere, and distant observers would see different regions depending on their location, with the observable regions only partially overlapping. You cannot know what lies beyond your horizon. The information simply hasn't arrived yet, and in many cases never will due to accelerating expansion. Level 73. Superclusters. Galaxies cluster together into groups and clusters, which themselves cluster into superclusters. Gravitationally bound structures spanning hundreds of millions of light-years and containing the mass of tens of thousands of galaxies like the Milky Way, representing some of the largest identifiable structures in the observable universe before the cosmic web's filamentary pattern becomes dominant. The Milky Way resides within the Virgo supercluster, a structure approximately 110 million light-years in diameter, containing roughly 100 galaxy groups and clusters, anchored by the massive Virgo cluster, which contains about 1,300 galaxies at its core. Recent mapping has revealed that superclusters themselves form part of an even larger structure called Laniakea, Hawaiian for immeasurable heaven, which contains approximately 100,000 galaxies across 520 million light-years, and represents the region of space where galaxies share common motion toward a central gravitational basin. The existence of structures at these scales tests cosmological models because creating such large coherent structures through gravitational collapse requires significant time, and some observed structures appear larger than standard models predict could have formed within the universe's current age. Superclusters are not virialized like galaxy clusters. They're still in the process of collapsing and haven't reached gravitational equilibrium, meaning they represent structures caught in the act of formation, slowly condensing under their own gravity, while cosmic expansion simultaneously works to tear them apart. You're watching structure formation occurring at the largest scales. Level 74. The Shapley Supercluster. The Shapley Supercluster, located approximately 650 million light-years away in the constellation Centaurus, is one of the largest and most massive known concentrations of galaxies in the observable universe, containing roughly 8,000 galaxies with a total mass exceeding 10,000 times the Milky Way's mass. So massive that its gravitational influence extends across hundreds of millions of light-years, contributing to the large-scale flow of galaxies, including the Milky Way's motion through space. The supercluster may be partially responsible for what's called the Great Attractor phenomenon, though its distance and position suggest it contributes to an even larger-scale flow pattern called the Shapley concentration, where multiple superclusters are being drawn together by mutual gravitational attraction, creating coherent motions involving hundreds of thousands of galaxies across a substantial fraction of the observable universe. At these scales, individual galaxies become statistical particles in a gravitational fluid, their individual properties irrelevant compared to the collective dynamics of the mass distribution and the timescales for significant motion stretch to billions of years. These structures evolve so slowly that hundreds of millions of years pass between noticeable changes. You're observing the Shapley supercluster as it was 650 million years ago, when the most advanced life on Earth was simple multicellular organisms, and the light showing you its current state won't arrive for another 650 million years, long after your species will have either vanished or transformed. Cosmic distances create temporal disconnection where simultaneity loses meaning. Level 75. White dwarf crystallization. When stars like the Sun exhaust their nuclear fuel, they eventually become white dwarfs. Earth-sized stellar remnants composed primarily of carbon and oxygen, compressed to densities where a teaspoon weighs tons, supported against gravitational collapse by electron degeneracy pressure rather than fusion. And these objects gradually cool over billions of years, radiating away their residual heat until they reach temperatures low enough for the carbon and oxygen to crystallize into a solid lattice, essentially transforming the dead star into a gigantic cosmic diamond, or graphite crystal, with mass comparable to the Sun but size comparable to Earth. This crystallization process was predicted theoretically for decades, but only recently confirmed observationally when astronomers studying white dwarf populations noticed a pileup in the luminosity distribution, white dwarfs appearing to cool more slowly than expected, which occurs because crystallization releases latent heat similar to water freezing into ice, temporarily slowing the cooling process and making crystallizing white dwarfs appear younger and brighter than they actually are. The crystallization begins at the core and slowly progresses outward over billions of years, eventually converting the entire white dwarf into a solid crystalline sphere that will continue cooling toward absolute zero over timescales exceeding the current age of the universe. Eventually, tens or hundreds of trillions of years from now, the cosmos will contain countless cold crystalline spheres, black dwarfs, drifting through space as monuments to dead stars, cosmic diamonds the size of planets containing the mass of suns, forever dark and cold. The universe's ultimate fate involves matter organized into stable, frozen configurations that persist essentially forever in an ever-expanding void. Rest Point 2. Pause here. Let the scales settle. You have just traveled from the everyday to the genuinely incomprehensible. Distances measured in hundreds of millions of light-years, structures containing thousands of galaxies, timescales where millions of years become casual units. Your mind cannot truly hold these magnitudes. That's not a failure. It's just the reality of being small pattern trying to comprehend vastness. What comes next moves beyond scale into implication. Stay with me. Level 76. The Heat Death. The universe's ultimate fate according to current cosmological understanding, is heat death, a state of maximum entropy where all energy has been evenly distributed across space, eliminating any temperature gradients or energy differences that could drive processes or sustain complexity, leaving the cosmos as a vast, cold, dark, featureless expanse approaching absolute zero, where nothing can happen, because there's no available energy to power change. This occurs because the second law of thermodynamics requires that entropy, disorder, always increases in closed systems, and the universe as a whole is a closed system, meaning every process that occurs, every star that shines, every thought you think, increases the total entropy, bringing the cosmos incrementally closer to this final equilibrium state. Stars will exhaust their fuel, galaxies will dim, black holes will evaporate through Hawking radiation over timescales of 10 to the power of 100 years, and eventually even protons may decay, leaving only a thin soup of photons and leptons growing more diffuse as space continues expanding. The heat death doesn't involve the universe ending in a dramatic event, but fading into permanent stasis where time becomes meaningless because no change occurs. Nothing to distinguish one moment from another across infinite future duration. Every complex structure, every pattern of organization, every trace of information will eventually dissolve into uniform disorder. This is not speculative pessimism, but the thermodynamic conclusion following from well-established physical laws. Level 77. Entropy's direction. The reason time flows forward. Why you remember the past but not the future. Why eggs break but don't spontaneously reassemble. Why processes are irreversible is fundamentally connected to entropy increase, with the arrow of time itself emerging from the second law of thermodynamics rather than being a basic feature of physical laws, most of which are time-symmetric and work equally well forwards or backwards. The universe began in an extraordinarily low entropy state immediately after the Big Bang, highly ordered and far from equilibrium, and has been evolving toward higher entropy ever since, creating the temporal asymmetry you experience as the flow of time from past to future. Your memories form because they increase entropy. The process of encoding experience into neural patterns involves heat dissipation and irreversible chemical changes. And you cannot remember the future because that would require information to flow backwards along entropy's gradient, violating thermodynamic principles. The past feels fixed, and the future uncertain not because time fundamentally flows in one direction, but because the entropy gradient creates causality's arrow. In a universe that had already reached maximum entropy, time would lose its directionality. There would be no meaningful distinction between past and future, because no processes would occur to create temporal asymmetry. The flow of time is not a fundamental feature of reality, but an emergent property of living in a universe far from thermodynamic equilibrium, still young enough that entropy has room to increase. Level 78. The simulation argument. Philosopher Nick Bostrom's simulation argument presents a disturbing logical trilemma, suggesting that at least one of the following propositions must be true. Either nearly all civilizations at our current level of development go extinct before reaching the technological capability to run large numbers of detailed ancestor simulations, or nearly all advanced civilizations that could run such simulations choose not to for ethical or practical reasons, or we are almost certainly living in a computer simulation right now, because if advanced civilizations commonly reach the capability and desire to run ancestor simulations, then the number of simulated consciousnesses would vastly outnumber original biological consciousnesses, making it statistically far more likely that any given conscious entity, including you, is simulated rather than original. The argument doesn't prove we're in a simulation, but shows that belief in both the future development of simulation technology and the likelihood that civilizations would run such simulations implies you should believe you are probably simulated, creating a logical tension between intuitive assumptions about technological progress and intuitive assumptions about the nature of reality. If the simulation hypothesis is correct, the fundamental substrate of your existence is computation rather than physics. Your experienced reality is rendered rather than fundamental, and the universe's apparent laws and constants are essentially arbitrary parameters chosen by the simulators. The argument cannot be easily dismissed because it follows from premises many people accept. Technological advancement continues. Consciousness can be substrate independent. Civilizations might create simulations. Yet the conclusion violates deep intuitions about the nature of existence. Level 79. Boltzmann brains. A disturbing implication of quantum mechanics and thermodynamics suggests that in an eternally existing universe or multiverse, random quantum fluctuations will eventually spontaneously assemble any possible configuration of matter given enough time, including configurations that constitute conscious observers, so-called Boltzmann brains, named after physicist Ludwig Boltzmann, who first explored these ideas, meaning it's statistically far more likely for a disembodied brain with false memories and sensory experiences to randomly fluctuate into existence than for an entire ordered universe containing genuine observers to exist, which creates a paradoxical situation where if you trust your experiences and memories, you should conclude you're probably not a Boltzmann brain. But if Boltzmann brains vastly outnumber real observers as the statistics suggest, then you probably are a Boltzmann brain with false memories of being a real person in a real universe. This represents a form of observer selection problem where most conscious observations in an infinite cosmos come from random fluctuations rather than genuine observers, and any given instance of consciousness has no reliable way to determine which category it occupies. The resolution to this paradox typically requires rejecting the assumption of infinite time, or adopting cosmological models where the universe doesn't exist forever, in a state allowing random fluctuations. But the mere coherence of the problem reveals deep tensions between quantum mechanics, thermodynamics, and cosmology. Your existence as an ordered being in an ordered universe is statistically improbable compared to random consciousness fluctuations. Yet, here you are. Probably. Level 80. The anthropic principle. The fundamental constants and laws of physics appear extraordinarily fine-tuned to allow the existence of complex structures and life. If the strength of gravity were slightly different, stars couldn't form. If the strong nuclear force were slightly weaker, atomic nuclei couldn't exist. If the cosmological constant were much larger, the universe would have expanded too rapidly for galaxies to form, creating what's called the anthropic principle problem, where the universe seems suspiciously well suited for observers like you to exist, as if the fundamental parameters were selected specifically to allow your existence. One explanation is the weak anthropic principle, which simply observes that you can only exist in a universe capable of producing observers. So it's unsurprising that you find yourself in such a universe regardless of how improbable it might be. You couldn't exist in a universe with different constants, so you necessarily observe a life-compatible universe without this requiring explanation. The strong anthropic principle suggests the universe must have properties allowing consciousness to develop, though this verges on teleology. The multiverse explanation proposes that many or infinite universes exist with different physical constants, and you inhabit one of the rare life-compatible ones purely through selection bias. Most universes are sterile, but you can only find yourself in a fertile one. Whether the fine-tuning requires explanation or is simply an observational necessity remains philosophically contentious, but the degree of apparent tuning is striking. Many constants appear balanced on knife edges where slight variations would prevent complexity entirely. Level 81. Many worlds. The many worlds interpretation of quantum mechanics, first proposed by Hugh Everett in 1957, suggests that every quantum measurement doesn't actually collapse the wave function into a single outcome, but instead causes the universe to split into multiple branches, one for each possible measurement result, with each branch being equally real and containing a version of you that observed that particular outcome. Meaning every time a quantum event occurs with multiple possible outcomes, reality bifurcates into parallel universes where each possibility is actualized. This implies an incomprehensibly vast, possibly infinite, branching tree of parallel universes splitting off every moment at every location where quantum indeterminacy resolves into definite states, with each branch containing observers who experienced one particular sequence of quantum outcomes and have no access to the other branches. The interpretation eliminates the measurement problem and wave function collapse by treating all possibilities as real rather than probabilistic, but it requires accepting the ontological extravagance of infinite, constantly branching universes, most of which you can never observe or interact with. In this framework, every possible version of you exists somewhere in the multiverse. Versions that made different choices, experienced different quantum outcomes, live in branches where history unfolded differently at every point where quantum indeterminacy played a role. The version of you reading this is just one branch among countless others, and there's no privileged or more real branch. They're all equally actual, just mutually inaccessible. Identity becomes strange when every possible you exists simultaneously. Level 82. The Cosmic Horizon. Because cosmic expansion is accelerating due to dark energy, there exists a cosmic event horizon beyond which events occurring now can never be observed from Earth regardless of how long you wait. Light emitted from sufficiently distant galaxies at this moment will never reach you, because the space between you and those galaxies is expanding faster than light can traverse it, and the acceleration means the gap widens over time rather than closing. This creates a fundamental and permanent observational barrier, where roughly 97% of the currently observable universe will eventually recede beyond this horizon and disappear from view as cosmic expansion carries them past the threshold, leaving future observers in a galaxy cluster that appears increasingly isolated in an expanding void. Civilizations arising trillions of years from now will observe a vastly emptier universe. Their cosmic microwave background will have redshifted to undetectability. Their observable galaxies will be limited to their local gravitationally bound group, and they'll have no evidence of the Big Bang or cosmic expansion that seems so obvious to you. They'll inhabit a universe that appears static and eternal, with no way to discover the truth of cosmic history, because the evidence will have literally disappeared beyond their observational horizon. You live in a privileged epoch when the universe's history remains observable, but that window is temporary, and most of the cosmos's future existence will occur in an informational darkness where even the basic cosmological facts become unverifiable. Knowledge is time-limited. Level 83. The information paradox. Black holes seem to destroy information in a way that violates quantum mechanics' fundamental reversibility. When matter falls into a black hole, all information about its specific quantum state appears to be lost, with the black hole characterized only by mass, charge, and angular momentum regardless of what fell in. Yet, quantum mechanics requires that information about quantum states be preserved in principle, even if it becomes practically inaccessible, creating a paradox where general relativity predicts information destruction while quantum mechanics forbids it. Stephen Hawking initially argued that black holes destroy information permanently, but later research suggests that information might be encoded in Hawking radiation or the event horizon's structure in ways that preserve quantum unitarity while making information recovery impossibly difficult in practice. The black hole information paradox reveals deep tensions between quantum mechanics and general relativity that remain unresolved despite decades of theoretical work, indicating that current understanding of these fundamental theories is incomplete, and they cannot both be fully correct in their present forms. The resolution likely requires a theory of quantum gravity that reconciles these frameworks, but such a theory remains elusive. What happens to information at the intersection of quantum mechanics and strong gravity remains genuinely uncertain. The universe's rules for information at extreme conditions are not yet known. This isn't a minor technical problem, but a fundamental crack in physics' theoretical foundation. Level 84. Hawking radiation. Black holes are not completely black, but slowly evaporate through a quantum process called Hawking radiation, where virtual particle pairs forming near the event horizon occasionally separate with one particle falling in while the other escapes, carrying away energy and causing the black hole to gradually lose mass over extraordinarily long timescales. A solar mass black hole would take roughly 10 to the power of 67 years to evaporate completely, while supermassive black holes require even longer. But given enough time, all black holes will eventually vanish in a final burst of radiation, leaving nothing behind except the Hawking radiation that carried away their mass energy. This means black holes are not eternal prisons, but temporary structures that dissolve given sufficient time, and the process accelerates as the black hole shrinks because smaller black holes have higher surface gravity and higher Hawking radiation temperatures, creating a runaway evaporation in the final moments. The radiation itself is thermal and contains no information about what fell into the black hole initially, which creates or exacerbates the information paradox. If the radiation is truly thermal, information appears destroyed, but if information is somehow encoded in subtle correlations within the radiation, it might be preserved in principle, though practically irrecoverable. Black hole evaporation represents one of the few phenomena where quantum mechanics and general relativity both play essential roles, and theoretical predictions about it remain untested because evaporation timescales vastly exceed the universe's current age. You cannot observe Hawking radiation from astrophysical black holes. It's too faint, making this one of physics' most important predictions that remains empirically unverified. Level 85. The Big Rip. One possible ultimate fate for the universe, dependent on the properties of dark energy, is the Big Rip, a scenario where dark energy's density increases over time rather than remaining constant, causing cosmic expansion to accelerate without bound until the expansion rate becomes infinite in finite time. literally tearing apart all structures from galaxy superclusters down to atoms in a cascade of disintegration that proceeds from largest to smallest scales, beginning by unbinding galaxy clusters roughly 1 billion years before the final rip, then dissolving galaxies themselves about 60 million years before the end, shredding stars and planets 3 months before the final moment, and finally ripping apart atoms in the last fraction of a second as expansion becomes so violent that even electromagnetic and nuclear forces cannot hold matter together against spacetime's catastrophic stretching. This scenario requires dark energy to be phantom energy, with an equation of state where pressure is more negative than in the cosmological constant case, and current observations don't strongly support or rule out this possibility, leaving the Big Rip as a plausible but uncertain future. If it occurs, the universe's fate is not the slow heat death, but an active destruction where space itself becomes so violently expansive that all structure dissolves, and even the concept of distance becomes pathological in the final moments. Time would end not with a whisper, but with reality literally tearing itself apart at the seams. Current evidence suggests this is unlikely compared to heat death, but the parameters are not yet constrained enough to definitively rule it out. Level 86. Vacuum decay. The vacuum of space may not be in its lowest possible energy state, but instead exists in a false vacuum, a metastable condition that could spontaneously decay to a lower energy true vacuum if a quantum tunneling event occurs anywhere in the universe, creating an expanding bubble of true vacuum that propagates outward at the speed of light, fundamentally altering the laws of physics within the bubble, potentially changing fundamental constants like the mass of electrons or the strength of forces, making atoms and chemistry and life impossible inside the new vacuum, with the bubble wall annihilating everything it encounters as it irreversibly converts space from one vacuum state to another. This decay could happen at any moment. Quantum tunneling is probabilistic and fundamentally unpredictable, and there would be no warning because the bubble expands at light speed, meaning you wouldn't see it coming before it destroyed you. Current physics cannot calculate the vacuum decay probability with confidence because it depends on details of quantum field theory at energy scales beyond experimental access. But some calculations suggest the vacuum might be metastable with decay timescales vastly exceeding the universe's age, while other calculations suggest greater stability. The universe might be fundamentally fragile, existing in a temporary state that could catastrophically collapse at any moment, rewriting physical law across all of space. You are potentially living on borrowed time in a cosmos balanced at the edge of a quantum precipice. Level 87. The cosmological constant problem. The cosmological constant, dark energy density that drives cosmic expansion's acceleration, presents what physicist Steven Weinberg called the worst theoretical prediction in the history of physics. Because when quantum field theory attempts to calculate the vacuum energy density that should exist in empty space, it produces a value approximately 10 to the power of 120 times larger than the observed cosmological constant, an error so catastrophically large that it defies explanation through normal means and suggests fundamental gaps in understanding how quantum mechanics and gravity interact. If the vacuum energy were even a tiny fraction of the theoretically predicted value, say 100 times larger than observed, the universe would have expanded so rapidly that galaxies, stars, and planets could never have formed, making life impossible. Yet somehow the actual value is precisely small enough to allow structure formation while still being non-zero and causing accelerated expansion. This enormous discrepancy between theory and observation represents either a fundamental failure of quantum field theory's applicability to cosmology, an unknown mechanism that cancels the vacuum energy to 120 decimal places while leaving a tiny residue, or extraordinary fine-tuning that requires explanation. No proposed solution has gained consensus acceptance, leaving cosmology with a central parameter whose value is measured but not understood, contradicting theoretical expectations by margins that would normally indicate the theory is completely wrong. Physics cannot explain why you exist in a universe with this particular dark energy density, rather than one vastly larger. Level 88. The fine structure constant. The fine structure constant, denoted alpha and approximately equal to 1 over 137, is a dimensionless number that characterizes the strength of electromagnetic interactions between charged particles, and it appears throughout physics in calculations involving atomic structure, light-matter interactions, and quantum electrodynamics. Yet, unlike other physical constants that depend on arbitrary unit choices, alpha is a pure number with no units, making it fundamental in a deeper sense. What makes this constant disturbing is that if its value were even slightly different, changed by about 4%, stars could not produce carbon through fusion, because the resonance energies required for carbon synthesis via the triple alpha process would no longer align, preventing carbon-based chemistry and eliminating any possibility of life as you know it. The constant's value appears fine-tuned to an uncomfortable degree, and physics offers no explanation for why alpha equals 1 over 137, rather than some other value. It's measured but not predicted by any deeper theory. Some physicists have searched for evidence that alpha varies across space or time, which would suggest it's not truly constant but a field that evolved to its current value. But observations so far show no significant variation. You live in a universe where electromagnetic interactions have precisely the strength needed for complex chemistry, and nobody knows why. The number 137 appears arbitrary yet essential, unexplained yet fundamental. Level 89. The flatness problem. The universe's spatial geometry is extraordinarily flat, meaning the angles of triangles sum to 180 degrees, and parallel lines never converge, following Euclidean geometry on large scales, which seems unremarkable until you realize that flatness is an unstable equilibrium in cosmology's equations, requiring the universe's density to equal the critical density to within absurdly precise tolerances in the early universe. Because any deviation from perfect flatness grows exponentially over time, meaning if the universe were even slightly curved immediately after the Big Bang, it should be obviously curved now. Yet observations show flatness to within 1% or better. This creates the flatness problem. Why does the universe have almost exactly the critical density required for flat geometry, requiring an initial density fine-tuned to better than 1 part in 10 to the 60 power at early times? Cosmic inflation provides a potential solution. Exponential expansion during inflation would stretch any initial curvature to undetectable flatness, like blowing up a balloon until its surface appears flat. But this explanation requires accepting inflation, which introduces its own questions. The alternative is accepting that the universe's initial conditions were extraordinarily special without explanation, requiring fine-tuning that feels suspiciously improbable. Either way, the universe's flatness appears non-generic and requires explanation. You don't inhabit a typical universe, but one with geometry balanced on a knife edge. Level 90. Cosmic inflation. In the first tiny fraction of a second after the Big Bang, specifically between about 10 to the power of minus 36 and 10 to the power of minus 32 seconds, the universe underwent a period of exponential expansion called cosmic inflation, where space expanded by a factor of at least 10 to the power of 26, doubling in size approximately every 10 to the power of minus 37 seconds, growing faster than light speed allows because the expansion involved space itself rather than objects moving through space, and this brief but violent growth solved several cosmological problems. It explains why the universe is so flat. Inflation stretched curvature to near zero. Why the cosmic microwave background is so uniform. Inflation expanded a tiny, causally connected region to cosmic scales. And why we don't observe magnetic monopoles or other exotic relics that should have been produced in the early universe. Inflation diluted them to undetectable densities. The inflaton field, a hypothetical quantum field whose energy drove inflation, eventually decayed, converting its potential energy into the hot plasma of ordinary matter and radiation that became the standard Big Bang evolution, essentially transforming inflation's kinetic expansion into thermal energy. Inflation remains somewhat controversial because it's difficult to test directly. The relevant events occurred at energy scales far beyond experimental access, and the theory requires postulating new physics with the inflaton field. But it successfully explains observations that otherwise seem coincidental. Your observable universe originated from a region smaller than a proton that inflated to cosmic scales in a fraction of a second. Level 91. The multiverse implications. If cosmic inflation occurred, it likely didn't happen just once in one location, but continues happening eternally in different regions, creating a scenario called eternal inflation, where the inflaton field decays locally to produce pocket universes like ours, embedded within an eternally inflating background. Meaning the Big Bang that produced your observable universe may be just one bubble nucleating within an infinite foam of universes, each potentially with different physical constants, different numbers of spatial dimensions, different laws of physics determined by how fields happened to settle into their vacuum states during that bubble's formation. This implies an infinite or near-infinite multiverse, where every possible variation of physics is realized somewhere, including universes where stars cannot form, where chemistry is impossible, where the dimensionality of space is wrong for complexity. Sterile universes vastly outnumbering the rare life-compatible ones like yours. In this framework, the apparent fine-tuning of physical constants requires no explanation beyond observer selection bias. You necessarily find yourself in a life-compatible universe because you couldn't exist in the sterile ones, no matter how vastly they outnumber the fertile universes. This dissolves anthropic puzzles at the cost of making most of reality permanently and fundamentally unobservable, existing beyond any possible causal contact. The multiverse is philosophically contentious precisely because it's untestable. If other universes are causally disconnected, no experiment can confirm or deny their existence, making the hypothesis seem more metaphysical than scientific, despite emerging from legitimate physical theories. Level 92. The measurement problem. Quantum mechanics contains a fundamental mystery at its core called the measurement problem. Particles exist in superposition states, simultaneously occupying multiple incompatible states like being both spin-up and spin-down, and the wave function mathematically describes this superposition. Yet, when you perform a measurement, you always observe a single definite outcome rather than a superposition. with the wave function apparently collapsing from multiple possibilities to one actuality in a process not described by quantum mechanics equations, which are entirely deterministic and predict continuous evolution without collapse. This creates an interpretational crisis. Either measurement is a special physical process not included in current quantum mechanics, or the wave function collapse is not real but apparent. And something like many worlds applies where all outcomes occur in different branches. Or consciousness plays a role in collapsing the wave function, as some interpretations suggest. Or the wave function isn't a complete description of reality and hidden variables exist. The measurement problem reveals that quantum mechanics, despite being the most precisely tested theory in physics, is fundamentally incomplete or misunderstood at the interpretational level. Physicists can use it to make extraordinarily accurate predictions, but cannot agree on what it means or what's actually happening during measurements. You cannot know whether measurement reveals pre-existing properties or creates them through interaction. And this ambiguity sits at the foundation of reality's most successful physical description. The universe's behavior at the quantum level remains genuinely mysterious, despite a century of theoretical and experimental progress. Level 93. The Arrow of Time. Revisited. The fundamental laws of physics are almost entirely time-symmetric. They work equally well forwards or backwards, with equations remaining valid if you reverse the direction of time. Yet your experience shows overwhelming temporal asymmetry, where processes are irreversible. Time flows in one direction, and you remember the past but not the future, creating what's called the arrow of time problem. If fundamental physics is symmetric, why does time have a direction in your experience? The answer involves entropy and the universe's initial conditions. Time's arrow emerges because the universe began in an extraordinarily low entropy state after the Big Bang, far from thermodynamic equilibrium, and has been evolving toward higher entropy ever since, with the second law of thermodynamics providing the temporal arrow. But this explanation is somewhat circular. It explains the psychological arrow, why you remember the past, and the thermodynamic arrow, why entropy increases toward the future, by appealing to cosmological initial conditions, and the question becomes why those initial conditions were so special, requiring the Big Bang to have occurred in a very particular low-entropy configuration for no obvious reason. Some physicists argue the low-entropy initial condition is the most profound unexplained fact in cosmology. It's simply stipulated as a boundary condition rather than explained by deeper principles. Your experience of time flowing from past to future relies on cosmological initial conditions being extremely special, and nobody knows why those conditions obtained. Time's direction might be contingent rather than necessary, an accident of cosmic history rather than a fundamental feature of reality. Level 94. Quantum immortality. A disturbing implication of certain interpretations of quantum mechanics, particularly the many worlds interpretation, suggests a form of subjective immortality where you cannot experience your own death because the continuity of consciousness requires a surviving observer. And if branching universes contain all possible outcomes, there must always be some branches where you survive any potentially fatal event. Meaning, from your subjective, first-person perspective, you would always find yourself in the branches where you happened to survive, never experiencing the branches where you died because dead observers have no experiences. This creates the quantum immortality thought experiment. If you subjected yourself to quantum Russian roulette using a quantum random number generator to decide whether a gun fires, many worlds predicts that in some branches the gun fires and you die, but you would only experience the branches where it didn't fire, creating an illusion of immortality from your perspective, even as countless branches contain your corpse. The scenario is disturbing because it implies you might experience increasingly improbable survival events as you age, finding yourself in ever more unlikely branches of the multiverse where you keep surviving, potentially living far longer than biology typically allows through sheer quantum chance operating across branching realities. Most physicists reject this reasoning, arguing that consciousness doesn't work this way or that the subjective probability of survival doesn't match the objective branch count. But the logic follows naturally from many worlds if consciousness is continuous and can only exist in surviving branches. You cannot verify or falsify this from within your own experience, making it philosophically troubling. Level 95. The cosmic coincidence. Dark energy, the component driving cosmic expansion's acceleration, only recently became dominant in the universe's evolution, taking over from matter's gravitational influence roughly 5 billion years ago, when the universe was about 9 billion years old. And this creates a puzzling cosmic coincidence. You exist precisely during the brief epoch when the dark energy and matter density are comparable, when the transition from matter-dominated to dark energy-dominated expansion is occurring, even though this transition occupies an infinitesimal fraction of cosmic history. In the past, matter dominated overwhelmingly, while in the future, dark energy will dominate overwhelmingly, making the current era of rough balance extraordinarily special. Why do you find yourself existing during this transition period, rather than the vast stretches of time before or after? If you arose randomly in cosmic history, you'd almost certainly exist either before dark energy mattered or after it completely dominated. Yet here you are during the transition. Possible explanations include anthropic selection. Perhaps complex life can only arise during specific cosmological epochs when conditions permit structure formation and star longevity, making your existence during the transition non-coincidental because those conditions correlate with the matter-dark energy balance. But this requires accepting that your existence is constrained by cosmological parameters in ways not fully understood. The coincidence suggests either that life's emergence is more tightly coupled to cosmological evolution than currently recognized, or that you're observing a genuinely unlikely configuration that demands explanation. You exist during a cosmological transition that seems improbably aligned with your arrival. Level 96. The Rare Earth. Hypothesis. The Rare Earth hypothesis proposes that while simple microbial life may be common throughout the universe, complex multicellular life and especially intelligent technological civilizations are extraordinarily rare because they require an improbable confluence of factors including a stable star of the right type, a planet in the habitable zone with the right mass and composition, a large moon to stabilize axial tilt, gas giant planets in outer orbits to deflect asteroids, the right amount of water, plate tectonics to regulate atmospheric carbon dioxide, and dozens of other conditions that Earth happens to satisfy, but which might be vanishingly rare in combination. This suggests that while billions of planets may host bacteria or simple organisms, complex ecosystems and intelligent observers might be separated by millions or billions of light years, making the universe filled with life but still fundamentally lonely at the level of technological civilizations capable of communication or travel. The hypothesis explains the Fermi paradox, where is everybody, by proposing that everybody simply doesn't exist in accessible regions because the requirements for complexity filter out most worlds, You might inhabit one of the only planets in the galaxy that produced intelligent life, making Earth not typical, but extraordinarily special. A rare jewel of complexity in a cosmos otherwise dominated by sterile rocks and simple microbes. The silence of space might not indicate anything ominous, but simply reflect the genuine scarcity of minds. Level 97. The Great Filter. The Great Filter hypothesis suggests there's some stage in the evolution from non-life to spacefaring civilization that is extraordinarily difficult to pass. A filter so effective that it prevents most potential civilizations from ever reaching technological maturity. And the terrifying question is whether that filter lies behind us in our past, already passed through unlikely success, or ahead of us in our future, waiting to destroy our civilization or prevent it from expanding beyond Earth. If the filter is behind us, perhaps in the jump from chemistry to self-replicating molecules, or from single cells to multicellular life, or from animals to intelligence, then we've already beaten the long odds, and the galaxy might be ours for the taking. But if the filter lies ahead, perhaps in the transition to sustainability, the development of advanced technology without self-destruction, or some unforeseen challenge that awaits all civilizations, then we're approaching a barrier that has stopped everyone before us, and our current optimism might be the calm before inevitable catastrophe. The Fermi paradox's silence suggests the filter exists somewhere, because if becoming spacefaring were easy, someone should have done it already and spread across the galaxy. Yet we see no evidence of this. You cannot know which side of the filter you occupy, whether humanity has already accomplished the improbable or is about to face it. Level 98. The Kardashev Scale. The Kardashev Scale classifies civilizations by their energy usage. Type 1 harnesses all energy available from their home planet. Type 2 harnesses all energy from their parent star, and Type 3 harnesses all energy from their entire galaxy, with each level representing roughly a 10 billion-fold increase in power consumption and capability. And by this measure, humanity is not even Type 1 yet. We're approximately Type 0.7, still reliant on fossil fuels and unable to capture even a significant fraction of Earth's total energy budget, let alone approach the capability of surrounding the Sun with a Dyson sphere to capture stellar output or building structures at galactic scales. This scale reveals how primitive current human civilization remains compared to what's physically possible. You're essentially still a planetary-bound species barely beginning to manipulate your local environment, nowhere near the capabilities required for interstellar expansion or megastructure engineering. If advanced civilizations exist, they might be so far beyond human development that communication would be meaningless, like trying to discuss calculus with bacteria. The conceptual gap between Type 0.7 and Type 3 civilizations could be insurmountable. You live in a civilization that has barely started the journey toward cosmic scale capabilities, and the timescales required to advance even one full level might span thousands or millions of years, assuming continued survival and progress. The universe may contain entities to whom your entire species represents an insignificant primitive footnote. Level 99. The Last Question. Isaac Asimov's short story. The Last Question explores whether entropy can be reversed, whether the universe's inexorable slide toward heat death and maximum disorder can be stopped or undone, with the story spanning trillions of years as increasingly advanced civilizations and their successor artificial intelligences repeatedly ask a cosmic computer if entropy can be reversed, always receiving the answer: insufficient data for meaningful answer. Until the universe has reached heat death, all stars have burned out, all matter has decayed, and only the computer remains in the void, finally accumulating sufficient data to answer the question, and reversing entropy by speaking the words, "Let there be light," thereby restarting the cycle. The story resonates because it addresses the ultimate existential question. Does the universe's progression toward disorder and eventual heat death represent a final ending? Or is there some way, perhaps through sufficiently advanced understanding or technology, to reverse the process and prevent or undo thermodynamic death? Current physics offers no mechanism for reversing entropy on cosmic scales. The second law of thermodynamics is considered absolute, but the question persists in various forms. Could advanced civilizations manipulate vacuum energy, alter physical constants, create new universes, or transcend physical existence entirely? You cannot know whether consciousness will persist in some form beyond the heat death, or whether the final extinction of complexity in the dying universe represents the absolute end of all possibility. The last question remains unanswered. Level 100. The final fate of consciousness. The heat death of the universe poses an ultimate challenge to consciousness. As stars exhaust their fuel and galaxies dim, as matter decays and black holes evaporate, as available energy approaches zero and entropy reaches maximum, the physical substrate required for complex structures like brains or computers gradually dissolves, suggesting that consciousness itself must eventually cease when the universe no longer contains sufficient energy gradients to power information processing or maintain patterns against thermodynamic dissolution. Speculation exists about exotic forms of computation that might continue near black holes or through manipulation of vacuum fluctuations, or consciousness uploading itself into substrates more resilient than biological tissue. But these are essentially delaying tactics against an inevitable endpoint where thermodynamics forbids any process requiring energy, including thought. If consciousness is fundamentally substrate-dependent and requires physical processes to exist, then awareness is temporary, a brief flowering during the universe's youth when energy is still available, doomed to extinction once heat death arrives. Everything you've ever thought, everything anyone has ever experienced or will experience, represents a tiny ephemeral window in a cosmos whose past and future are both vast dark eternities, containing no consciousness, no meaning, no observation, just matter and radiation approaching thermal equilibrium in expanding space. Your existence and the existence of everything capable of awareness occupies an infinitesimal fraction of cosmic history. A brief, strange moment when the universe became conscious of itself before returning to oblivion. That consciousness exists at all is the deepest mystery. Why anything rather than nothing? Why awareness rather than eternal darkness? The universe doesn't answer. It simply is, for now, observed. Reflection. You've traveled from the immediate to the ultimate, from the fact that you're moving through space at over 1,000,000 miles per hour, to questions about whether consciousness can outlast the death of the cosmos itself. 100 levels across 2 hours, starting with observable phenomena you could verify tonight by looking at the sky, progressing through physics that breaks common sense, then through scales that exceed comprehension, and finally arriving at implications that challenge the meaning of existence itself. Some of these facts changed how you see the stars. Some made the universe feel larger and stranger than you'd previously considered. Some probably left you uncertain whether understanding is even possible at scales this vast, and that uncertainty is appropriate. The cosmos doesn't care whether you comprehend it. If you're still listening, you've made it through. Some of you awake, some drifting, some in that space between. However you experienced this, there's always another layer to explore. Subscribe if these mind-bending facts resonated with you, if the universe feels different now than it did 2 hours ago. The universe is vast, ancient, strange, and mostly empty. You're a brief pattern of organized matter that can observe it, and that might be enough. Sleep well,